this will be the last. Hopefully this will be the last part of the series on the electron book. What is the electron? Let me turn my monitor down a little bit. So this was edited by Volodimir Simulik. A survey of theories on the electron, and I think this is my fourth part. I'm going to try to definitely finish it because now I can go. I figured out how to go longer on library videos anyway. So, okay, this chapter is electron as a periodic waveform of spin 1/2 symmetry by Horace R. Drew, New South Wales, Australia. And he's got a little quote here. Authors write many things, and the common people cling to them through arguments made without experiment. So we'll get into this and see what his ideas are here. And see if I can kind of simplify them and go on to the next one. And for the purpose of this review, I would like to explain the general concepts which underlie my recent work in theoretical physics or astronomy without going into technical details that may be found in the original papers. Today, in 2005, both modern physics and astronomy seem to be continuing in a state of crisis. Quantum mechanics and relativity remain as far as ever from unification. Theories of light and matter, such as QED, remain unpalatable with their false infinities and ad hoc schemes of renormalization. High-energy particle physics has become increasingly expensive and unproductive, with hundreds of different unstable particles discovered, but only a highly parameterized QCD theory to explain them. Similarly, astronomy has become dominated by a cosmological concern to prove the Big Bang Theory and to find an elusive dark matter. More importantly, perhaps, the possible uniqueness of currently accepted physical or astronomical theories seems highly doubtful. In physics, students are taught the Born-Bohr interpretation of quantum mechanics, as well as the Lorentz-Einstein view of special and general relativity, as if those were unique breakthroughs of a historical stature. Yet, any assertion of uniqueness are demonstrably not true. For example, in quantum theory, many early workers, including Schrödinger, de Broglie, and Bohm, disagreed vigorously with the proposed Born and Bohr that the electron could be only a point particle whose location in space or time might be found just probabilistically by squaring an abstract wave function. More recently, Simulik and Krivsky have shown that the electron may be treated as an electromagnetic scalar wave in a medium with full accuracy of experimental predictions, just as for the Dirac equation. In relativity theory, the Lorentz-Einstein view has had some success, yet has led also to many paradoxes. Between experiment and theory, for instance, the twin paradox for time or the spinning disk paradox for Ehrenfest. Furthermore, it makes a first-order prediction concerning Thomas precession, that is, retrograde motion of any rotating object due to length contraction, that appears experimentally not to be true, a discrepancy noted by Phipps and galaxy. Next, in astronomy, students are taught the uniqueness of the Big Bang Theory and are even taught to regard dark matter as a real thing, just awaiting formal discovery. Yet a series of leading astronomers, including Hoyle, Burbridge, G. Burbridge and M. Burbridge, Narlikar, and H.C. Arp, argue that the universe may not really be expanding at all if the mass and the time counting rate of particles were lower billions of years ago than today as a kind of natural evolution. By a similar and still quite heretical view, quasars need not lie at huge Hubble distances from Earth. If they were to be composed of newly created matter, which might have a lower intrinsic mass, as for ancient matter in the past. Finally, the dark matter hypothesis to explain abnormally large frequency shifts of spectral lines across single galaxies or galaxies in clusters become necessary if mass and time counting rates are not absolute, but may vary slightly over broad astronomical scales depending on the underlying energy of a zero-point vacuum. We should listen to experience as well as theory concerning quantum phenomena. Having suggested the lack of uniqueness for many accepted theories of physics or astronomy, let me now present a revised conceptual understanding of those two fields based on my long experience in X-ray diffraction as well as molecular biology, on my correspondence with workers in many fields of science, as well as much study at home. When studying these ideas, we should remain open to the advice of Roger Bacon from 700 years ago and let experience be our guide. In other words, when people of the 13th century England saw a rainbow and wished to attribute it to mystical powers, Bacon would say, no, it's not mystical at all. Look at a waterfall with the sun shining on it, or the range of colors created by light passing through a crystal, and you will see a similar thing. Of course, I'd like to disagree, though, with Bacon in terms of that doesn't make it any less mysterious. Reality still remains as mysterious just because you have connected some similarities. Doesn't mean that it becomes trivial in any way. It's still, this is the whole purpose of the book, is trying to grapple with the nature of reality and understanding that. My understanding, of course, is that it's the origins of reality are not accessible in our dimensionality. But let me go on here. In modern times, such practical advice is still useful. For example, we can see that many natural objects discretely colored as either red, blue, or yellow, or green, etc., from those simply visual observations, an uneducated man could deduce the general nature of quantum phenomena even without knowing probabilistic quantum mechanics. Thus, from much direct experience, let me suggest gently to the reader that the photon cannot be a point particle, nor can the electron be a point particle. Rather, both photon and electron must possess some internal, highly periodic structure through both space and time in order to diffract as observed. Even outside of the laboratory, we can watch light diffract as it passes by sharp edge or through a meshed fly screen. Indeed, most natural fluid substances will break spontaneously into some periodic structure of their own accord and will never remain random under all circumstances. From experience, we see that water will break into regular waveforms while running down a hill. Similarly, clouds will break into regular waveforms as they are pushed by airflow in the sky. When X-rays pass through a crystal, some of them are deflected or diffract at various precise angles and intensities to one side. What actually seems to happen on a microscopic scale is that the original X-ray waveform breaks up into smaller, undetectable fragments of precise phase, which are scattered through space by electrons within crystalline atoms. Then those many dispersed fragments may join together to form a new detectable photon, probabilistically in proportion to the square of their concentration in space, since at the fundamental level they seem to be composed of dimetric filaments. Indeed, the very nature of inertia on a macroscopic scale may be derived from a loss of phase coherence on a microscopic scale, although this fundamental and important idea has not been widely recognized. For example, whenever an electron diffracts in phase or follows a closed path of integral de Broglie phase in atoms, no inertia seems to be observed. David Bohm has included those strange inertialess phenomena in his alternative version of quantum mechanics and argues that particles moving under the influence of an in-phase guide wave need not show any inertia whatsoever, which is just another way of saying the same thing. Bohm's view have been strongly supported by modern quantum experts such as J.S. Bell or S. Goldstein. But the same process of photon or electron creation in diffraction would be treated very differently by Born or Bohr. They would formulate their model in terms of some point photon without any internal periodicity, which relocalizes instantly into a new spatial location that can be determined only by squaring an abstract wave function. Next, in order to convince a point photon to diffract, they have to invent an ad hoc principle known as wave-particle duality, where the photon can sometimes be a wave with well-defined intensity and phase, and sometimes just a dimensionless point. Perhaps Born and Bohr model seemed plausible in 1930 when it was first applied to very simple particles such as the electron or photon, but today, 2005, how can we possibly explain the diffraction of large multi-atom molecules by such an approach? For example, when a porphyrin ring from biology shows diffraction phenomena in a gas phase, where might the information come from to reconstruct accurately that multi-atom structure? If the entire porphyrin, supposedly according to Born and Bohr, collapse first to a dimensionless point that moves instantly elsewhere without inertia and finally is recreated with perfect reliability in some location. Surely in this limit of diffraction by large chemical structures, the Born-Bohr model may be considered implausible or even absurd. Alternatively, by Bohm model for diffraction, a hypothetical de Broglie guide wave would be the only part of that multi-atom porphyrin to experience interference. The major part of that complex chemical structure would remain intact and undisturbed and would just follow the in-phase guide wave through one slit or another in an inertialess fashion. Hence, our multi-atom porphyrin would never need to collapse to a dimensionless point nor be recreated in some new location. Finally, the Bohm-de Broglie guide wave could possibly represent some weak, externally detectable aspect of a much more energetic internal periodicity. not seen for a particle at rest, but seen for a particle in motion. In other words, the slightly higher mass of a moving particle could cause its very energetic internal periodicity, not detectable for a particle at rest, to spill over into space around itself, thereby causing wave-like diffraction phenomena for otherwise material particles. In summary, as noted above, most current theories in physics or astronomy are not unique. We can choose between Bohm's guide wave or Born-Bohr's point wave duality seemingly at will. To this author, the former theory seems plausible in terms of physical concepts. Going now beyond simple concerns for uniqueness, the consequences of adopting Born-Bohr model for modern quantum electrodynamics are shown. There we can see a randomly moving point electron will not easily be able to generate any finite energies in its electrical interaction with light. For example, a hypothetical point electron of radius r0 will repel itself by an infinite amount. It will also interact with an infinity of photons of all possible wavelengths as it travels randomly through space, yet it will not know how much of its total energy to commit to any electron-light interaction. Hence, the number precisely 1 over 137.03599 has to be put into the theory finitely by hand. Nor will the point electron even be able to proceed easily from one location in space or time to another, since it has no continuous structure in either dimension. That 1 over 137.3, so forth, that's the permeability of space, of the vacuum. I suppose that's what that is. See if you can see that little diagram. I don't know. Let me try to get that in front of the camera. It's going to be very difficult, but oh, there it is. Okay. So you see one's quite random and the other is quite regular. Okay. Infinite QED quantum electrodynamics is based precisely on those random, unstructured principles, and hence requires many essential parameters to be added by hand. Moreover, the point model generates at least 3 different kinds of spurious infinite energy that have to be removed by a mathematical trick known as renormalization, dividing one near infinite quantity by another. Dirac was very knowledgeable concerning such faults and therefore never accepted infinite QED as any more than an abstract calculating tool. By contrast, we can next examine the consequences of adopting a continuous and periodic waveform for the electron as shown. That was the more periodic one, right? So by a philosophical approach more akin to Bohm-de-Broglie model for diffraction, now the electron's self-repulsion becomes finite because its radius is finite. Also, the finite electron will only be able to interact with a limited number of photons of discrete wavelength from the outlying vacuum, as it exchanges some finite mobile energy inside itself equal to 1 over 137 with a similar self-energy in other particles nearby. Hence, this number need not be added by hand. Its passage from one location in space or time to another will similarly be defined by the continuous periodic structure itself. Having considered the favorable interaction of a wave-like electron with light, it should be noted further that our periodic electron is dynamically stable in a Casimir sense, whereas the random point-like electron is not. In other words, all particles should experience an outward force that depends on their finite size due to inertial motional influence, as well as the electrical self-repulsions, which may be balanced by an inward pressure due to zero-point waves from the surrounding vacuum in order for any particle to be stable dynamically those two terms, outward and inward, should balance closely, which they do for typical periodic electron. For example, considering the periodic electron shown below, one finds that I guess it's E for energy out is 137 times E squared over 2R. Okay. But for any point-like electron, R or 0, both the outward electrical self-repulsion and the inward vacuum pressure, 8c over 4 pi, go infinitely to infinity. Only by omitting all mention of Casimir stability and experimental certainty can the electron point theorist rescue an otherwise impossible situation. Periodic waveform spin one-half symmetry. Based on the previous discussion, two general concepts should now be clear. First, physics in the 20th century had to make a choice whether they would follow the Bohr model, assuming point particles, or else a de Broglie-Bohm model involving guide waves. Secondly, having chosen a Bohr model, those physicists wished to extend their point model to encompass a wider range of phenomena, and so arrived at a strange and complex theory that we now know as infinite renormalized QED, which is highly successful in numerical sense, but an undisputed failure in a conceptual sense. But what if the original choice made in 1930 was wrong? Next, we should present some well-defined, plausible wave-like model for the electron in order to support the general assertion given above. Different contemporary workers have preferred different wave-like models. For example, the electromagnetic scalar wave of Simulik and Krivsky, or the three-dimensional springing ring favored by Parsons, and now back in favor, but a matter of personal choice. I prefer the model shown above, which you're not going to be able to see because it's so small, the drawing of which is intended to represent a doubly spinning continuous and periodic structure in 4 dimensions of both space and time. Okay, this is where it gets kind of complex. However bizarre this 4-dimensional wave model might seem on first glance, there are several sound reasons for preferring a well-defined structure in 4 nearly equivalent dimensions rather than a well-defined structure in 3 spatial dimensions, which can advance through time as a separate entity. First, we know by experiment that the electron shows a periodic symmetry of spin 1/2, which means that it must possess 2 separate axes of rotation. Thus, it must advance about one axis, the major, at twice the frequency that it advances about the other axis, the minor. Okay, the spin 1/2 symmetry is fundamental to building any sort of plausible model for an electron, just as, by analogy, C2 space group symmetry was essential to Watson and Crick for building a correct DNA model, 1953. One could perhaps build some kind of 3-dimensional model with the required spin 1/2 symmetry as a filamentous Moby strip, yet other experimental aspects of electron behavior suggest that the model should really be 4-dimensional. For example, G equals 2 for magnetism, which suggests that the area of the capture of the external light may be twice as large through time as through space, or the anomalous part of magnetic moment as 1 over 137 times 2 pi, which represents a slight extra self-energy through time, or squaring of its wave function to generate new particle upon diffraction, explained elsewhere in terms of dimetric 4-dimensional filament. Okay, so it's pretty interesting. It's just going to get more complex. Let me see. Variable character of time on a subatomic astronomical scale. Variable character of time of particles in motion. let me see if there's any kind of little conclusion here. A clear distinction between dynamics and perception also clears up an important issue regarding possible models for the electron. By a perceptive Lorentz covariant view, only point models would be allowed, especially due to a predicted length contraction for particles in rapid motion. But since we see now that such concerns are associated with light image distortions and not with dynamics, there exists no real objection to proposing wave-like models of finite size, as has been done here and elsewhere. Each individual particle will therefore count time in its own way, depending on Casimir relations between the outward self-energy of any particle, inertial electrical, balanced against an inward pressure from the zero-point vacuum, which itself need not remain precisely constant over large scales of space and time. Hence, there may be as many times as there are inertial frames on Earth, and perhaps across distant galaxies as well. To conclude, when searching for an improved understanding of difficult subjects such as quantum theory, relativity, or cosmology, we should listen to experience as well as theory, since most current theories in physics and astronomy are not unique. Also, we should try to understand all of these subjects together as a whole, so far as possible, in order to avoid the acceptance of theories of one field which contradict those in another. Okay, so that's basically kind of this idea that the electron is, getting its properties derived from. It looks to me like he's got the vacuum energy. I would say it looks like to me, the way I would describe this is vacuum energy kind of mimicking, responding to the existence and the motion of the electron. That makes a lot of sense. It's kind of like Planck's quote about the information matrix. So really, it's the information of the zero-point energy is actually not very random. it's very, very well informed in order to give the properties of the electron that it needs, so that you don't have to get into particle duality and point particles and so forth. Okay, here's one geometrical meaning of electron mass from breakdown of Lorentz invariance. Okay, it's a bunch of guys from Italy. We discussed the problem of let me see their names: Cardone, Marani, Mignani. Okay, in Turini, Italy. We discussed the problem of the electron mass in the framework of deformed special relativity. It's called DSR, a generalization of special relativity based on a deformed Minkowski space, a four-dimensional space-time with metric coefficients depending on energy. We show that by this formalism, it is possible to derive the value of electron mass from the space-time geometry via experimental knowledge of the parameter of local Lorentz invariance breakdown and Minkowskian threshold energy. For electromagnetic interactions, we put forward the suggestion that mass generation can be related to the distorted special relativity, to the possible dependence of mass on the metric background. Okay, so it's almost the same. It's almost the same theory we just read. It's very similar. Introduction: the problem of mass spectrum of known particle, leptons and hadrons, is still an open one from the theoretical side As a matter of fact, the standard model of electromagnetic weak and strong interaction is unable to say why a given particle has a given experimental mass. As to the carriers of the four fundamental forces, symmetry considerations would require they are all massless. However, it is well known that things are not so simple. Weak quanta are massive, and it is therefore necessary in the framework of the Glasgow-Weinberg-Salam model of electroweak interaction to hypothesize Goldstone mechanism, which gives weak bosons a mass by interaction with the still unobserved Higgs boson. Even the first, best known, and most familiar particle, the electron, is still a mysterious object. In spite of the success of Dirac equation, which explains the spin value and the magnetic moment of the electron, the origin of its mass is far from being understood. The classical electron theory, with the works of Abraham, Lorentz, and Poincare, attempts to consider the mass of the electron as purely electromagnetic origin, and is well known to be deficient in several respects. The basic flaw of this picture is due to the Earnshaw theory, which states that it is impossible to have a stationary non-neutral charge distribution held together by purely electric forces. Moreover, a purely electromagnetic model of the electron implies the occurrence of divergent quantities. Such infinities can be dealt with by means of renormalization process. In quantum electrodynamics, however, even in this framework, the value of the electron mass is not intrinsic, but only results from interactions with the vacuum, which is, what we were just talking about. But let's see where he's going to go with this. Is really weird. The modern view of the problem of the electron mass was pioneered by Wheeler and Feynman, according to which it is not of electromagnetic origin, but entirely mechanical. In this paper, we show that the electron mass can be obtained from arguments related to the breakdown of local Lorentz invariance in the framework of a generalization of special relativity, deformed special relativity, based on a deformation of Minkowski space with metric coefficients depending on energy. This assigns a geometrical meaning by expressing it in terms of the parameter delta of LI breakdown. The organization of the paper is as follows. We briefly introduce the concept of deformed Minkowski space and give explicit forms of the phenomenological energy-dependent metrics for the four fundamental interactions. The LLI breaking parameter for a given interaction is introduced, and we assume the existence of a stable fundamental particle interacting gravitationally, electromagnetically, and weakly, and show by imposing some physical requirements that its mass value expressed in terms of delta EM, I can't read that, it's a little bit too, is just electron mass. In section 5, we briefly introduced the concept of mass relativity in DSR. Deformed space relativity in 4 dimensions. Deformed special relativity as a generalization of special relativity based on deformed Minkowski space, assumed to be endowed with a metric whose coefficients depend on the energy of the process considered. The deformation is intended, deformation I'll call it, I guess deformation is intended essentially to provide a metric representation of the interaction governing the process considered, at least in a given energy range locally in stable space-time region. DSR applies a principle to all 4 interactions, electromagnetic, weak, strong, gravitational, at least as far as their non-local behavior and non-potential part are concerned. The generalization Minkowski space is defined as a space with the same local coordinates, x of m, the four vectors of the usual Minkowski space, but with a metric given by a metric tensor. We stress that this formalism of energy is to be understood as the energy of a physical process measured by the detectors via their electromagnetic interaction with the usual Minkowski space. Well, this is it's very complex. I'm not sure exactly where they're going with this. I mean, it seemed an awful lot like the previous one, where they're given the background, some special properties. Well, the energy, the motion of the electrons, given the property to the background, and I guess it's a feedback. Mass relativity in DSR, deformed special relativity. The consideration carried out in the previous section therefore relates the electron mass to the local breakdown of Lorentz invariance. Its mass would be then a measure of the deviation of the metric form of Minkowskian. The minimum measured mass of the particle would be related to the minimum possible metric deviation compatible with its interaction. Okay. Conclusion. The formalism of DSR described, among other things, in geometric terms via energy-dependent deformation of Minkowski metric, the breakdown of the Lorentz invariance at the local level parameterized by the LLI breaking factor. We have shown that within DSR it is possible, on the basis of simple plausible assumption, to evaluate the inertial mass of the electron and therefore its antiparticle, the positron, by expositing the expression of the relativistic energy of the deformed Minkowski space, the explicit form of the phenomenological metric describing the gravitational interaction, in particular its threshold energy and the LLI breaking parameter for the electromagnetic interaction. Therefore, the inertial properties of one of the fundamental constituents of matter and the universe find a geometrical interpretation in the context of DSR when local violations of standard Lorentz invariance are admitted. We have also put forward the idea of a relativity of mass, namely the possible dependence of mass of a particle on the metric background where mass measurements are carried out. This could constitute a possible alternative mechanism of mass generation to those based on symmetry breakdown in relativistic quantum theory. Okay, let's see here. On space vector structure of the electron. Okay, Tawari. See his little background. Tawari here. Former executive director of Nuclear Power Corporation. India. Okay. It was René Descartes, the French mathematician and philosopher, who, perhaps for the first time in a scientific sense, assigned a reality to the medium of space as a propertyless fluid entity, already known at the time as ether. According to Descartes, large cosmic ether vortices existed throughout the universe. One such vortex carried the planets around the sun, and countless smaller vortices aggregated into different sizes of universal matter, filling the whole of space. He explained gravity by the pressure and impact of ether on bodies and framed the principles of the inertial tendencies of matter for straight line motion based on the property of fluidity of a space substratum filled with ether vortices. The transmission of the then known magnetic forces and the force of gravity between the Earth and the planetary bodies found explanations in Cartesian philosophy with physical contacts between the interacting entities mediated by the intervening ether. The theory of Descartes at that time was the most convincing natural philosophy and was based on a single dynamic ether as the only reality of the universe. The theory remained in acceptance for almost a century after publication of Newton's Principia. Now, it's funny because that would be my natural. That would be my natural conclusion about how these things should work. There have to be all sort of. It has to be all kind of one thing, and just the same way as the images on a computer screen are all just pixels. Everything would just be voxels, and that makes a lot of sense. You got energy densities and voxels, basically. But that would be my intuition would take me there. And I don't think really Einstein did away with it. They said he did, but that's really up for question. Anyways, Newton's laws of motion took into account the principle of inertia for straight line motion as conceived by Descartes, and Galileo's experimental discoveries of freely falling bodies and their motion on inclined planes. But ether was not involved to explain the properties of mass, inertia, which were introduced in Newton's laws of motion and the force of gravity. Thus, the medium of space, except for its utility as a continuous fluid substratum for the transmission of light waves, was again made inert and inactive for transmission of forces, and this led to the reintroduction of the principle of action at a distance. Based on this principle, R.G. Boscovich tried to explain all physical effects, and further Coulomb and Ampere invoked it in explaining the mutual action of forces between charged bodies and electric currents. In contrast, Faraday's researchers led him to the conclusion that electromagnetic induction cannot take place without an intervening medium, that is, a field. Faraday introduced the concept of continuously varying electric and magnetic fields, signifying that space is a continuous substratum and action at a distance is not the basic principle. He also suggested that an atom could be a structure of fields of forces, electric, magnetic, and gravitational, existing around its central point. On the existence of ether, Faraday's belief was that it may have its utility in other physical effects, in addition to providing a medium for transmission of light. Based on Faraday's concepts, Maxwell's were equations using hydrodynamics to model ether, postulating that it was an incompressible fluid. Helmholtz conceived that the ether vortex filament as electric current, and W. Thomson believed that the magnetic energy is the kinetic energy of a medium occupying the whole space, and that electric energy is the energy of strain of the same medium. Atomic structure as a vortex motion was also proposed by Thomson and others, and after the electron's discovery, Lamour concluded that the electron is a structure in the ether and that all matter consisted of electrons only. It's really interesting. I think that if you have, here's the thing, if you, what does it mean? It's like those, you've seen those illustrations of gravity being, warp space-time, and you have like a vortex, and it's kind of a two-dimensional. It's like take the planet is like a ball rolling around in a two-dimensional vortex, and so it's drawn towards. Really, what's drawing it towards? See, you can do that. I mean, I don't really have a problem with space-time being flexible. You just have, I mean, the way you can do that is just have a density. It's so a gravitational field is just a denser amount of reality, voxels. So, if reality's coming to us in time increments, and so the closer to time increments, then the denser, the denser the gravitational field. I mean, you can do that. Makes a lot of sense. I don't know if it's necessary. I mean, if you're really going to look at that illustration with the planet, circling the vortex, the vortex wouldn't be two-dimensional; it'd be four-dimensional. And so, it's difficult to imagine. Like, where does it empty out? Where does it empty? Where does it? Now, I mean, if three dimensions are immersed, if three dimensions are immersed in the four dimensions, it's not so difficult, to construct that in your imagination. But this idea, this what is, the string theory and all this stuff with curled up dimensions, forget about it. It's boring. That's nonsense. It doesn't make. It should be the other way around. We're the three dimensions in the space time that we have is the curled up one, and any other dimensions are going to be infinitely expansive. So forget about it. You got to think the other way around. It's the complete opposite, But anyways, let's go a little further in this here. Serious problems arose in 1905 with the concepts of vortex structures, of atoms, electrons, in an incompressible fluid. One problem was that the dissipation of vortex motion, since the streamlines in a vortex may tend to dilate outward. Another problem pertained to the difficulty of the transmission of an electromagnetic field in this fluid at an enormous speed of light, for which, if its properties were considered akin to matter, the elasticity should be near to that of steel. While these difficulties were yet to be overcome, Einstein's theory of relativity, proposed around the same time, postulated the medium space as an empty extension, which meant no point of space had a velocity vector or velocity field, thus making the very existence of the ether superfluous. The space vortex structure of the electron, based on the writer's works, are described in this paper. Previous solutions to both the above problems, the high elasticity required for the fluid ether, as pointed out above, is avoided by postulating it as a non-material and incompressible fluid devoid of any known property of matter, such as mass, density, discreteness, viscosity, elasticity, or compressibility, etc. Further, if the properties of the mass and charge of the electron must be derived from the first principles proposed by Descartes, Faraday, Maxwell, and Thomson, then a massless and chargeless fluid that as a vortex can form the structure of an electron must be assumed. That the proof of this assumption, that the universal substratum of space with non-material properties has real existence, is provided by deriving the basic properties of electron, mass, charge, inertia, gravity, locality, etc. from space vortex structure, and by explaining its behavior in physical as well as quantitative terms as experimentally observed. The other problem, that of the outward dissipation of the vortex motion, is solved by introducing a discontinuity in the energy distribution at the vortex center, as discussed later. Wow, it's really interesting. Here's a problem. What do you do? What do you do with the term non-material? I mean, you could. I mean, see, non-material. Something's non-material. That means it's abstract. I mean, the only thing. See, this in the Bible you have two kinds of material and nothing else. You really don't have. I mean, you do have abstracts, but the dichotomy is not material versus abstract. It's finite material versus infinite material. I mean, you could do this with his model. Instead of using the term non-material, you could say some kind of it's finite versus infinite. So if it's in an extra dimension, it may as well be considered infinite, and I think it would give you the same results. An extra dimensional, space, for instance, it would give you the same results of just calling it non-material. I'm just one of these people. I don't like non-material. It doesn't mean anything. It's like the word nothing. It's like the existence of nothing. But at any rate, I will, just tolerate that for now. And postulates the medium of space throughout the universe is an eternally existing non-material continuous isotropic fluid substratum. Okay. 2. The medium of space has a limiting flow speed equal to the speed of light relative to the absolute vacuum, and a limiting angular velocity when in a state of circulating motion. The medium of universal space is eternal and endowed with motion. Okay, well, he's kind of, we're agreeing there. I think we're probably just more like semantics. The creation of electron requires breakdown of the flow of the fluid medium in space, hereafter referred to as space. A irrotational circular vortex of space with concentric streamlines considered an element of space, as shown, on which a tangential velocity field is acting. If this vortex pertains to a viscous fluid of density p, the mass of the electron will be dm equals pd a over dr. There will be a pressure differential on two surfaces of the element, as shown. Two equal and opposite forces acting on the element will be inwardly directed radial pressure, net force, and centrifugal force, giving such a relation. An irrotational circular vortex, it can be shown that the velocity of the space point at distance r from the vortex center is given by ur equals a constant. When a vortex of massless space is considered, there is neither inward force on the element due to pressure differential nor outward centrifugal force, because the property of mass is common to the origin of both these forces. On a circular streamline, each of the points, the velocity field creates a radial outward acceleration field that, acting simultaneously on diametrically opposed points, tends to create a tearing action to split open the continuous space. If the speed of the space circulation reaches limiting speed of light, which is the speed of light in an absolute vacuum, and the velocity field gradient around the center of the vortex becomes the postulated limiting angular rotation, the space breaks down, creating a spherical void, which is defined as a fieldless, energyless, and spaceless volume of nothingness. Okay, so here we go. At the vortex center, the radius of the void created follows the relation determined by the ratio and it's not given here. Oh, maybe this is at omega c over r. Okay, yeah, I guess that's the ratio there. So this is actually kind of interesting. You know, it's it kind of reminds me of a Birkeland current and a plasma focusing device or something like that. It only you're focusing space. You're focusing space to 0 point. Now this is interesting. I remember reading this before. It brought up a really interesting question. Can you have a vortex in a vacuum? I don't know. You know, probably pretty easy to experiment. You put one of these chambers that you can, you create a vacuum like a glass chamber with on a stir plate, and then you just vacuum out the air and see if the so you got it stirring up to the point where it's creating a vortex in the fluid, and I guess you just use water, and air, and you just vacuum it out and see if the vortex disappears. I don't know if you could have a vortex in a vacuum. And see, this guy's he's got one that's even more powerful than that, because you really try he's got a vortex in the 0 point energy vacuum space. I don't know. I don't know if you can actually do that. Fundamental particles of matter. Let's see if I can pick out some more interesting passages here. If there's only one fundamental particle of matter, it is inconceivable that the universe has different kinds of space, or many structures will vary basic properties with okay. If there's only one fundamental particle of matter, it is inconceivable that the universe has different kinds of spaces, or many structures with varying basic properties. Hence, it is postulated that the most basic property of the universal medium of space is expressed by a single universal constant, omega, that limits its angular rotation and leads to the creation of a fundamental stable vortex. While the void of a definite volume is enclosed within the space vortex, the vortex itself extends throughout the whole universal space through its velocity field. The space vortex structure, with a fixed volume of dynamically stable void at its center, is defined as the fundamental particle of matter. The properties of electric charge and mass of the fundamental particles and the energy fields associated with the structure are derived in the following pages. The generation of fields. The space in circulation at speed c within the volume of the spherical void prior to the creation, its creation, is qualitatively the basic state of energy. At the instant of the creation of the void, this energy is pushed out from within the void and distributed in continuous space as continuously varying gravity and electrostatic fields. The fields so created, emanating from the interface of the fundamental particle, become integral with the whole of the universal space on account of the property of the non-viscosity of space. The void enclosed within the diametrically stable interface at the center of the vortex, and the above field exists externally without any loss of strength. The properties of the fundamental particle described above identify it as the electron itself. Okay. Dimensions of the unit mass, energy of electron structure, angular momentum, spin magnetic moment, electrostatic field energy. He's got everything worked out here. Dielectric constant, permeability of constant, Gauss law, electrostatic and energy, electron vortex, gravitation, the annihilation of electrons and positrons, fundamental nature of light. Let me see if this isn't too technical. With the discovery of the positron in 1932, a new phenomenon of annihilation of electrons and positrons was observed. During this process, the spherical interfaces of the particles under strong electric attraction are brought together, and at a very close range, the particles superimpose on each other, thus stopping the oppositely directed space circulations around their interfaces, which leads to the collapse of the central void. In this process, mass vanishes and light is produced. It is evident that the void interiors within the interfaces of the electron and positive, being energyless, cannot emit any kind of energy, such as photons. The energy, velocity, and acceleration fields in the vortex structure of the particles pervades the whole of the universal space, both before annihilation and following annihilation. Following the annihilation, the process in which the electromagnetic and gravitational potentials are reduced to zero, a single shell of light seen as a pulse initiates from the superimposed interfaces. That's kind of an interesting idea. And this, it's kind of like so these things are, the electron and positron have all these properties, and they when they come together like that, it's kind of like, I guess it's kind of like if you were running alongside a light wave. It's going to lose a lot of the properties it had if you were stationary. Okay, let's see here. Magnetic fields, atomic structures, the limitation on the creation of only one size of stable void in space vortex that produces stable fundamental mass and charge at basic units very much simplifies the theory of atomic structure. With the electron as the fundamental particle of the atomic nucleus, it follows that all stable particles will possess mass in exact multiples of electron mass, there being no difference between rest mass and relativistic mass. Further, no stable particle with mass less than electron mass can ever be found naturally or created through artificial means in laboratory. Unstable particles with masses different from the electron mass are presumed to be some intermediate stage in the formation of stable particles like neutrons. Now, this is really interesting. I like that. This guy thought this through quite a bit. Stable particles such as protons and alpha particles are enclosed in space vortices that have the property of charge. The unstable particles with charge will also be enclosed within space vortices of varying strength. For the duration of their lifetime, a neutral particle like a neutron does not a overall space vortex around it, and hence, without an electric charge, it remains neutral. All stable particles, neutral in charge, will have spin axis of rotation. The charge of a particle from the charge equation will be the surface integral velocity field on its surface. An electron and a positron at closest possible range, 10 to the minus 10 centimeters, will undergo annihilation under electrical attraction unless the particles are translating relative to space and thereby producing a magnetic force of repulsion between them. Just as an electron is subjected to an inward accelerating field on its interface, all charged particles and nuclei with space circulation around them will have an inward acceleration field tending to crush the particles This inward force arises due to the existence of a void. Okay, this is interesting. Okay, the electron center. Now okay, that makes a lot of sense. The vortex structure and space circulation around the charged particle and the nuclei of atoms based on the above guiding principles arising from the space vortex structure of the electron, its observed properties and behavior, the possible structures of nuclear particles are described below. So that's kind of neat. So right, okay, so it's spinning, creates a vacuum, sort of, so to speak, I don't know what you call it, some kind of we'll just call it a vacuum for now, a cavity. But it's kind of like producing a low pressure field that pulls it in. So it's got that stability. This is a really interesting theory. Let's read this little conclusion. The medium in space is dynamic. In dynamic states, creates matter and its associated fields. The properties of mass and charge, the gravitational, electromagnetic, and nuclear fields are produced from most fundamental field. The velocity field and unified. Hold on, let me read this again. The medium of space in dynamic states creates matter and its associated fields. The properties of mass and charge, the gravitational, electromagnetic, and nuclear fields are produced from the most fundamental field, the velocity field, and unified in the electron structure. The property of inertia arises due to the reaction from space on the central void in the electron's vortex structure. The velocity of light relative to space medium is a common factor in all the basic universal constants so far experimentally determined. The electron is the fundamental particle matter. Okay, that's pretty interesting. I know, it's too bad this book didn't 2005. It was just probably right around when the Electric Universe guys were really getting started. Wallace Thornhill and his gang could have made an excellent contribution to this book. And I think the guy would have included him if you knew about him, because Bill Gates in here. Okay, so if you can have Bill Gates in the book, you have no problem putting Wallace Thornhill. Solving Nature's Mysteries, Structure of Electron and Origin of Natural Laws. Milo Wolf. Manhattan Beach, California. Okay, I like this guy's kind of... See, I was saying before, we're going to get into some of these kind of beach bum philosophers here, these surfboard philosophers. The structure of the electron is investigated and found to be the origin of the natural laws. The natural laws have been measured for hundreds of years, but no one knew how nature creates them. The origins had been proposed earlier by Clifford and Schrödinger as a wave structure of matter to explain natural laws. Einstein also wrote, "Physical objects are not in space, but these objects are spherically extended. In this way, the concept of empty space loses its meaning." All right, but Einstein, he didn't do a very good job of explaining. I mean, why didn't he just say that their physical objects are made of space? I mean, that's really what that's what you got to say. All right. Using WSM. Okay. So remember, WSM stands for wave structure of matter. Okay. Using WSM, quantitative origins have been found based on the wave structure of the electron described here. It is shown that the quantum wave medium is the single entity underlying electron structure and the laws. Two principles are found describing the wave medium, enabling calculation of properties of particles and the laws. The productive power of WSM is shown by deriving the previously unknown physical origin of the electron spin. WSM has important implications for research, industry, and humans' role in the universe. So remember, WSM, wave structure, matter. Now, we're going to have a little intermission. I'll put the music up. I got to go get a drink, and we'll just keep going. I'll be back. Oh. Okay, I'm back. I got one of these seltzer water things. Vizzy hard seltzer that I tried. Okay, so far now somebody told me. Okay, let me turn this down. All right, somebody told me, White Claw. Now I didn't try White Claw yet. I get this Vizzy. I tried Corona's seltzer waters, Budweiser seltzer waters. And actually, I like something with a little more flavor. I really like Mike's hard fruit flavors the most of all, I think. But I didn't try the White Claw yet. Once I try that, I'll see. But I mean, the nice thing about these seltzer water things, I mean, they're definitely not too sweet, but they're almost not enough flavor for me. But I guess the nice thing is, I think when you're done, you're not thirsty anymore. To me, that's the important thing. Okay. So here we go with Milo Wolf. Introduction. Einstein was once asked if he could understand the meaning of the enormous number of hadron particles being generated in giant accelerators. He replied, I would rather know what an electron is. Answering his question is the purpose of this article. At the same time, the reader will gain, in hindsight, an understanding of the deep meaning of his reply, not only his disinterest in accelerators, but also because the forces of the electron extend to infinity, revealing relationships of the universe and the natural laws which govern it. And I don't know quite why he says that, but I guess we'll find out. Let's give him a chance. Let's let him speak. Okay. And there's a little, maybe I can show you this diagram. And then I'll read what it says. I don't know how to get my camera to focus. The electron is composed of spherical waves which converge to the center and reverse. That's really interesting. Oh man, I love this. Okay, so here's what it does. Okay, so this is, wow, and this is it's really like kind of, it's an excellent alternative to the previous article, where the electron was, in a sense, creating a central vacuum. This comes in, converges and comes back out. So, but this it's kind of reinforcing itself. Now let me see. Okay, so it converges on the center, reverse to become outward waves. The two waves form a standing wave, whose peaks and nodes are like layers of an onion. The wave amplitude is a scalar number, like a quantum wave, not an EM vector. The center is the apparent location of the electron. Wow! Oh man! Wow! pretty interesting. Now, I mean, right away you kind of see problems with it, but I mean, where do you get the spin? Where do you get the angular momentum? I guess he's going to deal with that. First of all, okay, where do you get the angular momentum? The other thing I was thinking was, okay, I was theorizing. You have a wave in space, but going, see, here's the thing. Okay, this looks good in 2 dimensions. Well, it would look good in 3 dimensions also. It's going to run into, I mean, I see some problems already, like with the idea that you have orbitals. See, I mean, orbitals kind of require, not just a wave like this, but one that is flower shaped. Okay, so you need kind of this flower shape with an integer amount of petals in order to get your orbitals. And what happens if your frequency is so high? Can you have a frequency so high that the crests, the peaks start overlapping, and that's the origin of mass. I don't know that's kind of it's kind of, I mean, the flower shape thing is not too sloppy, but I don't know how you can. Well, okay, here's why I say that. Okay, because let me show you what I was talking about. Okay, so let's suppose. Okay, so you got the flower petal kind of orbital thing here going. All right, so there's 4, right? So imagine you get the super high frequency. Okay, so your super high frequency. I mean, there's a lot higher of frequency right there. And it's just going to get tighter and tighter. What happens in the center? Your crests are getting closer and closer together, and on the outside, in the perimeter, they're getting further apart, and you have that quality where light bends when it's going through a different medium, so to speak, and so. Your crests and your peaks are going to be actually experiencing 2 very different 0-point energy densities. But also, I mean, what happens if they actually get a high enough frequency where the troughs are actually starting to touch one another? I don't know if that could happen, and then that would create a vortex. In my really way out theory. They're probably not worth discussing right now. So anyway, our knowledge of science is based on natural laws that describe the behavior of particles. The laws are the rules for calculating electricity, gravity, relativity, quantum mechanics, and conservation of energy and momentum. The origins have been unknown. Now the origin of the natural laws is found to be a quantitative result of a wave structure of matter, WSM. The basic concept is very simple. The ancient Greek notion of a point particle, still in use today, is replaced with a spherical wave structure, which had already been predicted by Clifford and Schrodinger long ago. The figure that I just showed you shows the structure of an electron in its inward wave that converges on to a center, spherically rotates, creating spin, and becomes an outward diverging wave to form a standing wave. The endless wave combination are like the 8th note musical scale that becomes grand symphonies of Wagner and Beethoven. Wow, it's pretty interesting. And I'm just not trying to find fault here. I'm just, because the guy's, it's kind of blowing my mind, and right away it's making me, want to bounce off of it. I'm trying to bounce off of it here a little bit. I want to, what I mean? Because, okay, if you got this standing wave and it's completely spherical, not that a sphere can't spin, but it seems to me it has to have some other kind of structure. It has to, other for orbitals anyway. But okay, let's keep going. The rules of the wave combination are of great importance to science because the rules of quantum spin determine the atomic table and contains the varied form of matter, metals, crystals, semiconductors, and molecules of life. The deep understanding of basic physics that is revealed opens a door to broad fields of applied technology such as integrated circuits, medicine, and commercial energy. It reveals a universe of real quantum wave structure and a space medium that we live in but seldom are aware of. The medium is the basis of matter and the universe because its properties underlie the wave properties. Okay, yeah, well, that's see, a lot of these theories all have that consistent, they're not doing away with the ether. They're consistently, the way I put it is the structures come from, in a sense, the shape of space. The space has all these qualities. And, you shape it, you move it, and so forth, and it if it gets real dense like this, you get mass, you get things like electrons and so forth. Space, human senses, and survival. We don't easily see space wave medium because our survival as an animal species depended mostly on our ability to fight with other animals, seeking food, and to compete for mates to produce children not closely related to the quantum space medium. I don't like these evolution theories. I can do away with them. I mean, a lot of the Leonard Susskind was always saying this about, wow, it took us so long to find quantum mechanics because we were too busy, fighting off saber-toothed tigers or whatever, But the thing is, it doesn't add up. It doesn't work that way. The human imagination and so forth, the human mind, if evolution were true, doesn't need to go beyond survival. Why do you need to have an imagination where you can start to discuss things like quantum mechanics? It's unnecessary. It disproves the theory of evolution. Anyway, our sensory mechanisms evolved to directly aid our survival, not to be aware of quantum waves. Our self-focused human perspective, few of us are even aware of the wave medium in which we exist. For survival, it doesn't matter. Okay, so he's made his point. He just needed one sentence, really. The situation is much like the life of a fish, in the water. Okay, we get the point. Our misrepresentations, our misconceptions are revealed by biological evolution. Blah, 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 blah. Lacking direct personal experience of simple quantum waves, people chose to imagine that an electron is a discrete particle, like a bullet. Laboratory evidence does not support this human-oriented idea. Accordingly, belief must change from discrete particles to true quantum wave structure. Now, I like that. That is an interesting way of proceeding in life. That is human-centric versus God-centric. Okay. I mean, we have a certain amount of human because we're humans. We you know, human centrism is not anything wrong with it. It's just not complete. You need God centrism to really, you know, put everything together. Human perspective has another bias. We tend to see space as three rectangular dimensions. Rectangular dimensions. One of which is vertical, gravity, vector of Earth, plus two other vectors perpendicular to it, shaped like the houses we live in. But in the cosmos, the shape of the enormous universe is spherical, whose important dimensions are inward and outward, the direction of waves in space. In the vast expanse of the real universe, gravity occurs so rarely that its direction is inconsequential in the larger scheme of things. Despite its local importance to us, unfortunately, we feel comfortable with rectangular coordinates and tend to ignore the spherical universe. The proof of WSM is the physical structure of the electron, and the empirical natural laws can be obtained mathematically from two basic principles describing wave-space medium. In other words, all the experimental measurements of historical physics that describe natural behavior are now predicted by two fundamental principles. The law and principles agree with each other. Each is the proof of the other. Physics of the wave structure of matter is simple. In contrast, old discrete particle structured physics required dozens of assumptions plus many more arbitrary constants to explain the operation of the laws. Many properties and laws, like electron spin, were puzzling with no understanding. The puzzles are now swept away. Particle structure physics can be compared to the theory of epicycles of the planets around the Earth. Before Galileo found that the planets traveled around the sun, discrete particles satisfy our human prejudice, but do not explain the measured facts. Now, you know, this is kind of interesting about the sphere versus the rectangle, or the square, the cube. There's the passages in the Bible. It's very fascinating that the new heavens, the new Jerusalem is going to come out of the sky in a form of a cube. It's not going to be a sphere. And by the way, if you know, here's the other thing: if you have an infinite, now I'm not dissing this guy's idea of the importance of the sphere, but if you have an infinite, you know, spatially infinite universe, what do you do with the sphere? Why does it have to be spherical? If it's infinite, it doesn't actually have a shape. And what does that mean? You know, when you lose shape. I mean, solid. Solid is confined. 4 dimensions, 3 dimension. Water takes the shape of the container, but you know, it's flat on top, so to speak. I guess even water in space will be liquid in space will be spherical. But gas is just go every which way. Comfortable physics and physical reality. Many people from old Greek philosophers such as Democritus and Pythagoras up to colleagues of Albert Einstein sought to understand the structure of the tiny atom and molecule in our everyday world. Until recently, most answers have been speculation created in analogy to human scale objects around us, like baseballs and bullets and grains of sand. Atoms were imagined to move like familiar objects such as moons around planets and toy tops spinning on a table. These analogies made us feel comfortable, so we preferred to ignore strange new ideas. As Churchill said, We often stumble onto the truth, but most of us brush ourselves off and pretend it didn't happen. He can include himself in that category. When he stumbled onto the bankers that financed him to bomb Germany, so that they could go to war with Germany, and he wouldn't take peace for an answer. Serious thinkers such as Einstein, Dirac, Schrödinger, Ernst Mach realized that analogies were wrong. Instead, experimental measurements showed that the structure of matter was closely related to the properties of the apparently empty space around us, and that the elements of matter had to A. have a spherical symmetry, B. be extended in space, C. possess a means of exchanging energy, and D. possess wave properties founded on wave equations. Their thinking produced conclusions that in hindsight were prophetic. For example, Einstein rejected the discrete point particle and stated, matter must be spherical entities extended in space. Erwin Schrödinger understood the requirements of particle structures when he wrote, 1937, what we observe as material bodies and forces are nothing but shapes and variations in the structure of space. Okay, that's what I was just saying earlier, right? I hope he has the Planck quote, but I don't think it's going to show up in this book. Particles are just Shanakkomen, that is, appearances. He believed that quantum waves were real, not probability distributions, as I do, right? Okay, yeah, the probability distribution, the probability wave thing is like the flying spaghetti monster, It's just it's so lame. With a particle hidden inside. He saw that abolishing the discrete point particle would remove the paradoxes of wave-particle duality and the collapse of the wave function. They arrived at their valid conclusions by painstaking analysis and careful adherence to the rules of logic and philosophy of truth. But their thinking was ignored for 60 years. Truth is no match for belief. Wow, that's a good line. I'm going to put that on a shirt. That's what oh man, that's very timely. I was, I wanted an idea for a shirt. Truth is hate. That's another thing. Truth is no match for belief. Machiavelli understood this human behavior 500 years ago. There's nothing more difficult to plan, more doubtful of success, more dangerous to manage than the creation of a new system. The innovator has the enmity of all who profit by the preservation of the old system, and only lukewarm defenders by those who would gain by the new system. The predictions of these pioneers, verified and described here, is that matter is a wave structure embedded in space. This result not only satisfies the experimental work, but surprisingly displays an immense but simple tapestry of physical universe. Awe-inspiring connection between matter, ourselves, and the cosmos are found. The application of the electron wave structure reaches out, on the one hand, to unsuspected fields of cosmology, such as the Big Bang. Oh man, Big Bang. Okay, the redshift, the structure of the universe. On the practical side, a new tool was provided that will enable us to deeply understand and improve the industrial devices such as computers, microcircuits, and efficient transmission of electric energy. Okay, as you know, I'm not a Big Bang proponent. Especially the way it's presented to us, like this creation ex nihilo, out of nothing. That's not for one thing, it's not biblical, but it's not logical. It's not mathematically. It doesn't add up because You can't start with nothing and end up with anything. For one thing, you know, this whole idea of starting with a singularity, you're starting with impossible preconditions. Why not just start with God? I mean, it makes a lot more sense. Just you know, it just makes a lot more sense. And so, God before the universe was already omnipresent and infinite, spatially infinite. I don't believe space was created. I think space always existed. I mean, that's how could God exist if there was nowhere for him to exist? You know, you had to have a somewhere. The only difference between what we experience as the universe and what God experiences is that we have lesser dimensionality. That you know, just the same way, you know, some of these theories have a vacuum in the center of the electron. I mean, that's sort of where the vacuum in the center of God's existence. Okay, so let's get rid of the Big Bang. Finding laws, space, and the structure of the electron. Finding the structure of the electron was a key finding of the origin. The origin of natural law. The business of physics is the abstract description and quantification of facts observed in nature. The rules we form for expression of the observed facts are the laws of nature. Since past laws were obtained by measurement of nature rather than derived from other knowledge, they are, by definition, empirical and of unknown origin. Well, of God origin. That's he could switch that unknown with God. But then, therefore, if we seek to find the origins of the laws, we cannot use the existing laws themselves, but must use other observed facts together with logic and established mathematics to find origins. The old empirical laws are only a guide, not the source. Accordingly, the search for origins must probe deeper into nature than heretofore, and we must be prepared to find new perspectives. The unexplained puzzles of nature are attractive sources of input data in the search. Finally, the proof of the origins of laws is a match between the observed empirical rules and the prediction of the new origins. Circular reasoning. When we seeking origins, it is important not to inadvertently use existing rules to deduce them. Such circular reasoning can occur if, for example, a mechanical model is assumed to be for the structure of an electron. Such common errors are the use of toy tops, sheets and rings of charges, masses are in orbit around each other. This is because the quantum laws of quantum particles can be extrapolated to large macro objects, but the inverse is not possible. Logically, finding the origins of existing laws requires forming new concepts that satisfy observed data. See, I'm of the opinion that the origins have to come from revelation, supernatural revelation. I don't think you're going to get origins from what we observe as our universe, because we don't have access to all the dimensions. So, you got to accept, like, if you were characters in an extremely sophisticated computer game, where the characters actually had volition and so forth. Well, maybe some of the really smart ones, they would figure out there's some kind of a mathematical relations to the way these pixels behave. But it would pretty much be impossible for them to deduce that there's somebody on the outside that had made and all the hardware and software and so forth that goes into the surrounding superstructure that is required just for the pixel world in the screen. The new perspective discovery of these origins creates a new perspective of the physical world. Quantum mechanics and relativity are united. A single origin of forces is found, puzzles and paradoxes are explained, and, most important, relationships between microphysics, electrons, and other particles in the universe, cosmology, are seen to be a result of an all-pervading space filled with oscillating quantum waves of the matter of the universe. We exist a sea of quantum waves. Connection, electron, and the laws. This part of the discussion of the relationship between electrons, the natural laws, and the universe. Let us examine the meaning of these words. Our concept of universe is a collection of particles and their distribution. This, without particular to populace a universe, this without particles to populate a universe, the universe concept has no meaning. Accordingly, our concept of our universe depends on understanding the particles in it. Especially, we need to understand the connections with the electron and proton, because the charge waves of those two particles extend throughout the universe. The natural laws have no meaning without particles, because laws require the presence of particles upon which the laws operate. Particles are also meaningless without laws to identify them. We conclude that understanding the connections between particles, laws, and the universe is essential to understand the whole. Each requires, let me put some light on here. Each requires the existence of the other. Therefore, we cannot understand cosmology unless we also understand the relationship within the trilogy above. Okay, and the trilogy is matter, universe, and laws. Okay, well, I see what I'd like to do with this. Okay, you got space meter. What I like to do with this trilogy is, what I do is have, for universe, I'll call it space-time. For matter, let me see, space-time. Oh yeah, space-time, energy and matter, and for law, information and consciousness. That's how I do this. He's got universe, matter, and laws. I would do space-time is 1, energy and matter is 2, and information and consciousness is 3. That's how you really got to construct that universe tripod. Okay. Measurement is a property of an ensemble of matter. Particle properties require perception, communication between particles. The measurement of time requires a cosmological clock. We live in an interconnected universe. New physics and old physics. Let me read that one. Okay. Study of wave structure of the electron and other matter is a new adventure, where you find the origin of natural laws and have revealing window on science, cosmology, technology, and ourselves. But first, old mainstream attitudes must be discarded. For instance, a conventional quantum physicist expects that all quantum phenomena must derive from Schrodinger's equation. No, it is the other way around. Schrodinger's equation is derived from the quantum wave structure of nature, of matter. Some concepts must be changed. For example, the meaning of charge and mass are not inherent properties of particles. Instead, nature has chosen, as Schrödinger deduced, that charge and mass are properties of the wave structure. And, as shown above, natural laws here on Earth depend on the matter of the rest of the universe. Goals of research need to be changed, knowing that the building blocks of the universe are the waves of the electron and positron. Accordingly, to be fruitful, physics must study the properties of the wave medium, not build accelerators. A short history of the wave structure of matter. Let's read that. It sounds interesting. Okay. Wave structure of matter was proposed 130 years ago by the famous English geometer William Clifford, who spoke before the Cambridge Philosophical Society in 1870. All matter are simply undulations in the fabric of space. He developed this concept as three-dimensional dynamics that reduced to four-dimensional kinematics, describing matter, electromagnetism, and kinetic energy as curvature of a dynamic Riemannian space. His work was the progenitor of the WSM, wave structure, matter, and general relativity. Clifford's thoughts, mass and charge, substances do not exist but are properties of wave structures in space. In short, space waves were real, while mass and charge points are mere appearances of wave structure. His proposals and those of Schrödinger were consistent with present-day quantum theory, since quantum mathematics does not depend on a belief in particle or charged substance. Ernst Mach and Bishop Berkeley had proposed about 1890 that the law of inertia depended on all the matter of the universe. This is known as Mach's principle. It was the first recognition that natural law depends on cosmology. Albert Einstein was greatly influenced by it when he deduced the general theory of relativity. Now, Mach's principle is a more exact form, has become the principle below, the wave structure of matter. Paul Dirac was never satisfied with the discrete point particle because the infinity of the Coulomb force law had to be corrected by renormalization. He wrote, "This is just not sensible mathematics. Sensible mathematics involves neglecting a quantity because it turns out to be small, not neglecting it because it is infinitely large and you do not want it." Of course, the inference is that the basic equations are wrong. The radical changes need to be made. Dirac seemed to foresee the WSM. In 1945, Wheeler and Feynman sought the cause of the radiation from an accelerated charge. Their calculations assumed that the charge generated equal amplitudes of advanced inward and retarded outward spherical electromagnetic waves. The outward waves evoked a response of the universe, that is, the production of inward waves from absorbing charges elsewhere in the universe. The absorber waves began before the arrival of the source waves. The calculated forces due to the combined local and absorbed waves agreed with Dirac's empirical formula and appeared to be the cause of energy transfer. Their remarkable result attracted much attention. However, Wheeler and Feynman pointed out that the derivation had not been rigorous. Especially, there are no electromagnetic wave solutions in spherical coordinates. In hindsight, the success of the W&F calculation was in part due to suppression of the vector character of the electromagnetic wave, so that, in effect, they were calculating scalar quantum waves. Below, it is shown that a scalar wave equation can rigorously produce two solutions, namely inward and outward spherical waves that have all properties of position and electrons, of positrons and electrons, excuse me. So, it's got me thinking, if the inner wave needs the outer wave, this had to be like a simultaneous creation, it's like what came first. Now, let's see here. Application of the wave electron. Let's see some more. This is pretty really interesting. Dirac's empirical formula for the force of acceleration was verified and found to be independent of the properties of the absorber, provided that absorption was complete. Remarkably, no inward waves appeared to violate causality because the inward waves formed the observer were cancelled upon arrival by interference with the waves from the source charge. The remaining wave field gave the disturbance demanded by experience in agreement with the prescription of Dirac. W and F, Wheeler and Feynman described their inward waves as orbital charges at a large distance produce spherical waves toward the source. At that moment, the source is accelerated. These waves just touch the source. Thus, all the waves from the absorber charges form an array of approximately plane waves marching towards the source. The envelope of these plane waves is a spherical ingoing advanced wave, and sphere collapses on the source, then pours out again as divergent outward wave. Here's the thing. I mean, we're kind of taught, you don't have a free lunch. There's no such thing, creation of energy or matter. The intrinsic energy of an electron never decreases. You know what I mean? It doesn't decrease. It's always there. Okay. Wave structure matter. The wave structure is space resonance. Space that's supposed void of which we formerly knew little is the medium of the wave and the leading player in this new physics of the universe. The properties of electrons, other matter, and the laws they obey are derived from properties of the medium, that is space, and space described by three principles underlie our knowledge of science. Principle 1, wave equation. Okay, there's the principle 1. Doesn't give you the other two principles. I don't see the other two principles. Oh, no, here they are. They're way up ahead. Okay. Space density principle. Oh, that's pretty interesting. Energy transfer and action in the distance paradox. Okay, that's what I was just talking about before. Okay, let's see. Properties of electron and positrons. The two-wave combinations contain all experimental electron-positron properties. Briefly, charge polarity depends on whether there's a positive or negative amplitude of the in-wave at the center. If a resonance is superimposed upon an anti-resonance, they annihilate. The amplitude at the center is finite as observed. The properties of quantum mechanics and special relativity are the result of Doppler motion of one space resonance relative to another. It's kind of energy transfer. Again, an important property not previously known is the mechanism of energy exchange. Experience tells us that communication or acquisition of knowledge of any kind occurs only with an energy transfer. Storage of information, whether in a computer disk or in our brain, also requires an energy transfer. Energy is required to move a needle, to magnetize a tape, to stimulate a neuron. There are no exceptions. This rule of nature is embedded in biology and our instruments. Finding the energy transfer mechanism between particles is essential in understanding natural laws. The first hint of a mechanism of cosmological energy transfer was Ernst Mach's observation in 1883. He noticed that the inertia of a body depended on the presence of the visible stars. He asserted every local inertial frame is determined by the composite matter of the universe, and jokingly, when a subway jerks, it is fixed stars that throw us down. His deduction arose from two different methods of measuring rotation. First, without looking at the sky, one can measure the centrifugal force on a rotating mass and use the inertia law, F equals ma, which equals mass times the velocity squared over the radius, to find circumferential speed and position, as in a gyroscope. The second method is to compare the object's angular position with the fixed stars. Both methods give exactly the same result. The inertia law appears to depend on the fixed stars. And even the fixed stars are really fixed. I guess unless you're into the flat earth and dome theory and so forth. Which, I mean, you technically you can't actually rule it out. I mean, unless you haven't, you got to actually go there to. Okay, let's see. Mach's principle was criticized because it appeared to predict instantaneous action and distance across empty space. How can information travel from here to the stars and back again in an instant? As Einstein observed, ideas and opinions in the Crown paperback book in 1954, forces acting directly and instantaneously at a distance as introduced to represent the effects of gravity are not in character with most of the processes familiar to us in everyday life. Action at a distance does not actually occur because nature's energy exchange mechanism is now seen as the interaction of space resonance with the ever-present universal medium of space. Space is not empty because it is the quantum wave medium produced below by waves from every particle in the universe as implied by Mach's principle. The energy exchanges of inertia, charge, and other forces are mediated by the presence of the space medium. There's no need to travel across the universe. You know what? I'm not quite sure what he's saying. That I mean, is he saying that the local space has the same qualities as if it was the mass of the stars? I don't know. I don't quite understand that paragraph. I mean, you could see. Here's what happens. Here's where I think I wish they had Planck's quote. No, I tried to save that somewhere. Let me see if it's on here. I think I got it in one of my files. Of course, it might crash my computer if I try to open a file. Let me see what happens. Okay, here we go. Because, this Planck quote really sum up everything this guy's trying to tell us. All right. Where is it? Oh, here it is. Okay, I think it's here. Okay. No. Okay, it's a different. I don't know where the file. Anyways. Okay, Planck was saying that that everything depends on this matrix of information. So, I mean, you don't need action. You don't need anything, really, because all you need is the information. If the information, in other words, if it's programmed in such a way, like if you have a computer game, let's say you have a soccer game on a computer screen, and the player kicks the ball, and the ball goes flying, and it's all simulated. It's simulated that there was mass in the player's leg that was transferred to the ball, and the ball took a trajectory. It was in a sense recreated over and over again on the screen to simulate a moving ball in space. I mean, you could do that three-dimensionally. I mean, God can do that. We can't, but God could do it. I mean, maybe we'll get the technology, and like if you saw Hunger Games, where they just they kind of press the dog button, and here comes the dogs. It's just the same way when Jesus created the fish that he fed, the fish and the bread that he fed the 5,000. The energy was there in the universe already. It's just you have to be God to to manipulate it like that. I mean, Jesus certainly, 2,000 years ago. I mean, maybe we'll get some kind of technology, where we can manipulate the density of energy in such a way eventually. But I mean, it certainly was for Jesus without any, he didn't have any, tools. He didn't, he didn't have the, some kind of, plasma focus device or something like that. He had access to command the energy to take these configurations, and so I mean you could just end up describing inertia that way. that it's a mathematical property given to the the structure of the universe, and that's how it works. All right, so minimum optical principle, conservation of energy, energy transfer mechanism occurs at the high density wave centers, which permits coupling or changes of the wave frequency. When the waves of a potential source and a potential receiver pass through each other's centers and an allowed transition exists between them, MAP, I'm not sure what MAP stands for here. Anyway, let me read a little bit of this paragraph above this here. This principle is disciplinary for the universe. That is, energy transfer takes place and wave centers move in order to minimize total wave amplitude. Amplitudes are additive so that if two opposite resonances move together, the motion will minimize total amplitude. This explains empirical rules such as like charges repel and unlike charges attract. Because those rules minimize the total amplitude, the origins of other rules are also now understood. For example, MAP, minimum amplitude principle. Excuse me. Okay, that's what that is. Minimum amplitude principle. And that's one of his third principles here. Okay, let's read. Okay, the third principle can be obtained from principle 2, and principle 2 was space density principle, in which we didn't really read. Space density principle. This principle defines the quantum wave medium space. It is fundamentally important because the properties of waves depends on the properties of their medium. But since the natural laws depend on the waves, we deduce that the natural laws in turn depend on the medium. Thus the medium space is the wellspring of everything. Principle 2. At each point in space, waves form. All particles in the universe combine their intensities to form the wave medium of space. He's even got a nice little equation here. Space density mc squared. I can't read it. But anyway, in other words, at every point in space, the frequency or mass of a particle depends on the sum of squares of all the wave amplitudes from n particles inside the Hubble universe. Well, forget about Hubble. Amplitude decreases inversely with the range squared. The Hubble universe has a radius c over h, which Hubble is the Hubble constant. Well, forget about Hubble. You're just confusing. You're just mudding up the waters for no reason, as far as I'm concerned. This principle is a quantitative version of Mach's principle because the space medium is the inertial frame. Okay, that's how. Well, that's what I was saying before. That means all the information, the same amount of information you get from all the stars is right there, is present everywhere. Well, see, that sounds like God created the universe. Anyways, okay, let's see here. The number of particles. But close to a large astronomical body like the sun, its Large space density produces a measurable curvature of the path inward and outward waves, and thus related to the motion of matter. We observe the curved paths of the effect of gravity described by Newton, and also space curvature in Einstein's general relativity. Okay. Alright. Appearance of the origin of charge. Schrodinger and Clifford predicted that charge was due to the wave structures in space. Charge appears at wave centers because the spherical waves of an electron resonance are very large at the center due to the 1 over r squared dependence. Centers have a high density due to the large wave amplitude. The dense space at the central region is nonlinear, which causes energy transfer or coupling between two resonances. We observe this process, we call it charge, but as Clifford and Schrodinger wrote, there's no charged substance involved. It is a property of the wave structure at the center. Okay, well, I mean, that makes sense. I mean, I can understand. It's kind of like, I mean, I just call it density of space. I mean, producing particle motion. Oh, it was high density wave centers appear to us as the location of a point charge because force interactions occur there. We call electric. The center wave amplitude is finite, as shown in Figure 3. Experimentally observed, it is not infinite as puzzling as in the puzzling Coulomb law. The in waves of the particle on arrival at the wave center produce position and motion in the center at what we observe as the particle. If any matter nearby changes the medium density, this changes in the wave speed and motion and moves the particle location. We observe the motion and describe it as the result of electric forces. Motion and acceleration of matter also changes the apparent wavelengths and produces energy exchange to the wave medium. Okay. Similar to the W and F response of the universe, inertial motion, F equals ma produces Mach's principle because the space density is formed by all the matter of the universe. So it's actually like, you could imagine, you could just think of the universe kind of like as a big lump of Play-Doh. Alright, so now let's see here. Conservation of energy. Energy transfer mechanism occurs. Oh no, we were principle 3. Yeah, okay, like principle 3. Principle 3. Okay, we done glitching now? Okay, alright. This is why glitch. Alright, maybe it's done glitching. Okay. Third principle can be obtained by principle 2, but because it is a very useful law of the universe, which simply describes how interactions take place, how wave structures will move, it will be written out separately. The total amplitude of particle waves always seeks a minimum at each location. Okay. This principle is disciplinarian of the universe. That is, energy transfers take place and wave centers move in order to minimize total wave amplitude. Amplitudes are additive, so if two opposite resonances move together, the motion will minimize the total amplitude. This explains empirical rules such as like charges repel and unlike charges attract, because those rules minimize total amplitude. The origin of the rules are also now understood. For example, minimum amplitude principle produces the Pauli exclusion principle, which prevents two identical resonances from occurring the same state. Two identical states are not allowed because total amplitude would be a maximum, not a minimum. The operation of the minimum amplitude principle is seen in ordinary situations like water of a lake, which levels itself, and in the flow of heat that always moves from a hot source to cold sink, which are examples of the increase of entropy principle. That's kind of interesting. I mean, that works for me. I guess, the energy transfer mechanism occurs at high density wave centers, which permits a couple of or changes in the wave frequency when the waves of a potential source and a potential receiver pass through each other's centers, and an allowed transition exists between them. MAP minimizes the total of both amplitudes by choosing the transition in the source, and frequency of the wave state shifts downward. In the receiver there is an equal shift upward. Only wave states, oscillators with equal frequencies tuned to each other can couple and shift frequency. Accordingly, the frequency energy changes must be equal and opposite. This is exactly the content of the conservation energy law, not too different from the rules of tuning up an orchestra to match A played the first five. Yeah, well, that's really interesting because it also would explain the periodic table, why some things are reactive and some things are interactive and some things are inert. The mechanism also describes the proposed noted by Einstein in his writing of the tetrode. When I see a star 100 light years away, the star knew that its light would enter my eye 100 years ago, before I was born. Tetrode was predicting that energy exchange is a two-way symmetrical resonance exchange between source and receiver, not a one-way photon. If you keep the traditional assumption that matter consists of points of mass and charged substance, and that energy exchange is a one-way EM photon traveling between particles, you're doomed to the paradox of causality, violation, wave-particle duality, Copenhagen errors, Heisenberg uncertainty, redshift, and others. Only the two-way exchange of WSM matches observation. Even though Einstein had originally proposed the photon, he never understood them. In 1954, he wrote to his friend Michael Bezzo, expressing his frustration. All these 50 years of conscious brooding I have brought me no nearer to the answer to the question, what are light quanta? Nowadays, every Tom, Dick, and Harry thinks he knows, but he is mistaken. Einstein also came to realize that matter could not be described by electromagnetic field. I consider it quite possible that physics cannot be based on the field concept, that is, on continuous structures, discrete particles. In that case, nothing remains of my castle in the air, gravitation theory included, and of the rest of the modern physics. In hindsight, he was correct about the errors of field theory, and his general relativity has survived. The origin of N waves and the response of the universe. At first thought, it was puzzling where the N waves came from. This puzzle is our own fault, a result of looking at the waves of only one particle and ignoring the waves of all other particles of the universe. Gross oversimplification. To find reality, we must deal with the real wave-filled universe. When we study this question, we find rational origin of the waves. Okay, let's see what 300 years ago, Christian Huygens, a Dutch mathematician, found that if a surface containing many separate wave sources was examined at a distance, the combined waves appeared as a single wave front having the shape of the surface. Oh, that's really cool. This wavefront is termed the Huygens combination of the separate wavelets. This mechanism is the origin of the N wave as follows. When an outgoing wave encounters other space resonances, that is particles, their outwaves are joined with the initial outwave to form a Huygens combination wavefront. These waves arrive in phase at the initial center, forming the N wave of the initial particle. This occurs throughout the universe, so that every particle depends on all other to create its N wave. Although particle centers are widely separated, all particles are one unified structure because they share each other's wave. This kind of begs the question, like, I always thought it was funny, these Big Bang proponents that um, make an appeal to the wave, the quantum wave singularity that needs a consciousness to collapse, but they're afraid to go to God. They're afraid to have a pre-existing God to collapse the initial wave. Now the thing is, the initial wave function. The thing is, I mean, that you don't need to do it that way anyway. I mean, you don't. The whole Big Bang thing is just, I just don't like it at all. It's just, you're starting out with an unscientific precondition. God is more scientific of a precondition. That's all there is to it. That's it. And this guy's got the same problem here with the what came first, the in wave or the out wave. See? The origin electron spin, an example of the depth of the understanding of the universality of the wave structure of matter, which describe the origin and the spin of the electron. The physical nature and cause of the electron spin has been sought for 75 years, ever since Nobel laureate Paul Dirac made a calculation of spin in 1926. His theoretical work predicted the positron, found 5 years later by Anderson. Well, that is really interesting, the whole prediction of the positron. Let me see if any of this. Dirac's theory. Dirac was interested in the differences between relativity and quantum theory. Dirac compared the conservation of relativistic energy and momentum of a particle with Schrodinger's procedure in quantum theory. Schrodinger's procedure was to use energy statement and change it to a wave equation. He changed the terms into a wave equation. The Schrodinger wave function. Then the solution should describe the amplitude of the waves of the particle. No one knew why this worked, but the result was the atom bomb. Okay, the H bomb. Okay. The procedure was puzzling. It uses square terms and cannot be squared. The reason that the equivalent of squaring could become a part of matrix algebra. He found that solutions existed for energy and momentum had fixed values. This theoretical matrix algebra produced correct fixed values of the electron's energy and spin, but it gave no hint at the physical structure of the electron. Dirac also noted that the only two functions were needed for the electron solution, theta solution. So Dirac simplified the algebra, introducing number pairs, spinors, 2 by 2 matrices. Physical mechanism of spin. Spin occurs when the in wave arrive at the center, change direction, and transform into an out waves. Okay, that's how spin. Strict boundary conditions on the transformation, amplitude, polarity of the in and out wave space cannot be allowed to twist up without limit. The spherical wave amplitude must continually and smoothly change from being in wave to out waves, and the in wave amplitude at the center must be equal and opposite to the out wave. It turns out that this transformation is possible using a known property of 3D space called spherical rotation. A misleading name. There is no true rotation in which space moves continually around a point and returns to its initial state after 2 turns. In spherical rotation, there is no axis like a cylindrical rotation of a wheel. Spherical symmetry is preserved because the center of rotation is a point. One direction rotation produces the electron, the other the position. This is why every charged particle has an antiparticle. Oh, wow, that's pretty mind-blowing. Batty, Pratt, and Racy in 1981 analyzed spherical rotation and showed that an exponential oscillator was a spinor. Wolf realized in 1989 that the exponential in and out oscillation waves of WSM were the real physical spinners satisfying Dirac's equation. It is humbling to realize that only 3D space has the remarkable properties shown. If this property of 3D space did not exist, particles of matter could not exist. Life in the universe we know could not exist. Okay, so let me see if I can make out this. I'll get my magnifying glass, but there's this illustration there. It looks pretty rather interesting, I must say. Let me see what it okay. Okay, this cork ball and rubber bands. Okay, so model of a spherical rotation. This apparatus is easily made out of a few sticks, a cork, and 6 rubber bands. The cork can be rotated, taking care not to knot up the rubber bands continuously without entangling the rubber bands. The cork and bands will return to their initial configuration every 2 turns. This demonstrates a little known variety of rotation. It has application to particle theory because the spherical rotation does not destroy continuity of space. That's really cool. That's probably right. That's probably right. I you know, it's got to be something like that. It makes so much. It makes most sense. Very coherent. The equivalence of WSM and Dirac equation procedure. It is easy to calculate the rotation rate of in-wave frequency energy mc over h and the wavelength h over mc. The rotation rate is 2 turns each cycle. This produces an angular momentum of h over 4 pi, obtaining Dirac's result simply. The energy value of electrons is the same for both, but of different signs, plus or minus h, Planck's constant. The Dirac equation yields plus or minus mc squared, while WSM says both electron and positron energy are positive, plus mc squared. Dirac was forced to interpret the puzzling negative energy as an unseen sea of negative energy particles. This strange concept has never been observed and has been abandoned. How can we understand Dirac's negative energy? Look at the electron-positron wave algebra in the appendix. Write the product of energy and time as negative, that is, minus E, it looks like E, let me get my thing out again here. Minus ET over H equals minus WT, but this is the same as switching. This is the same as switching the in wave with the out wave, which changes the electron into a positron. Now we see Dirac's result described an antiparticle, not a negative energy. He assumed the electron was a discrete particle instead of a wave structure. This mistake has plagued physics for centuries. But the thing is, I mean, if these in waves and out waves are how come, how come we're not living in a universe of an equal number of electrons and positrons? And there's not an explanation here for this. Spherical rotation in 3D space can be modeled by a ball held by threads inside a cubical frame. The threads represent the coordinates of space, and rotating ball represents space at the center of the converging and diverging quantum waves. The ball can turn about any axis starting from any initial position. If the ball is rotated continuously, it returns to its initial configuration after every 2 rotations. This demonstration appears in the classic book Gravitation by Misner, Thorne, and Wheeler. Oh, geez, I want to get that book. Let me write this down. Okay, so it's called Gravitation. Okay. Let me see here. Book, Gravitation. Okay. Meisner, Thorne, and Wheeler. Okay, so that's really interesting. Using the exponential wave solution for the electron shown in the appendix, you can reverse the spin axis, reversing time, reversing angular momentum. But it doesn't cover the fact that we got electrons and not positrons universe. Atoms in a crystal. Okay, this is kind of neat. Let's see what this atoms in a crystal thing is here. Okay, atoms in a crystal. The waves of the electron in the crystal array produce standing waves along the planes of symmetry. There's no solid structure, substance, or material in the crystal. It is the waves that produce the array dimensions, and it is the immense energy density of the space medium that gives physical strength and rigidity. Okay, so energy density still, it means something. It has to have some kind of physical reality. Okay. I better go to, this is super interesting though. Here's a discussion. Okay, let me read a little bit of this discussion here. We can have confidence that the word have is missing from we can have confidence that the wave structure matter is the true physical reality of the universe. The logical proof test is that the experimental measurements of the empirical natural laws must agree with their predictions by the WSM. They do. In fact, experimental evidence agrees better with the WSM predictions than with conventional rules. For example, an infinity of charge potential at R equals 0 is expected from Coulomb's experimental law. It is, Coulomb's empirical law. It is not found. Instead, the finite experimental value agrees with the WSM. There are more examples. Conventional physics has no explanation for energy exchange or the Pauli principle or spin or gravity or charge attraction, repulsion. All of these are predicted correctly by WSM. The philosophical conclusions from the connectedness of the laws of matter in the universe are thought-provoking. Everything we observe here on Earth, life, mind, matter, depends on the existence of matter elsewhere in the universe. Thus, if the stars and galaxies were not in the heavens, we could not exist. Matter on Earth and matter in the universe are necessary to each other. Einstein was close to the truth when he wrote, "A human being is part of the whole called the universe, a part limited in time and space. We experience ourselves, our thoughts, our feelings as something separate from the rest, a kind of optical delusion of consciousness. This delusion is a kind of prison for us, restricting us to our personal desire and to affection for a few persons nearest us. We must free ourselves from the prison by widening our circle of compassion, to embrace all living creatures and the whole of nature in its beauty. We shall require a substantially new manner of thinking if humanity is to survive." Well, I agree with, I disagree. I disagree with that. I think that individuation is a necessary part of being a finite being, and you can't just run roughshod over it with Buddhistic denial. It just doesn't, to me, that just doesn't add up. It's not you're not really properly reflecting reality if you have to push it outside of its own limits. I'm sorry. It's just just because you have an abstract idea that you find appealing doesn't mean that you can enforce it and change reality itself. Individuation is a necessary condition. You're not going to, you're not going to sweep it under the rug of, philosophical gobbledygook. That doesn't mean that you don't care about other people or anything. That's not my argument. But you can't just walk away from reality because you got this grandiose, I don't know what you call it, like a higher morality or whatever. origin of special relativity, mass increasing de Broglie wavelength. That looks interesting. Okay, here we go. Light neither particle nor transfer wave. Okay, this is William Gade, researcher from Columbia. He's on YouTube, and he's got this rope theory thing. Okay, so here we go. Statistics, variables, and equations and concepts such as energy, force, and field tell us nothing about the architecture of light, the atom, the universe. The mathematical theories of general and special relativity and of classical and quantum mechanics deal exclusively with relations and concepts and are therefore powerless to describe the shape of physical objects, to discern the architecture of an invisible entity. We must merely venture an assumption and logically check whether the proposal explains the observations. Pursuant to this method, we show architects of light, the atom, and the universe rebuff the abstractions of photon wave duality and wave packets, etc., inferred by classical and quantum mechanics. Keywords: particle, wave duality, wave packet, hydrogen atoms, static universe, dynamic universe. The moon does not move. For centuries, man has described whether the universe is static or dynamic. Newton was one who believed in homogeneous, infinite, and static universe, reasoning that only infinite mass and volume could counteract the gravitational attraction of stars and keep them essentially in place. In contrast, relativity champions a dynamic universe characterized by self-creation and inflation. However, technically speaking, Newton's universe is not what we really call motionless. Under his peculiar version of static, the moon still orbits a spinning planet, and a dog sleeping quietly here on Earth nevertheless moves with respect to Jupiter. If the plain meaning of the word static is having no motion, the Newtonian universe is ill-conceived. It is imperative, therefore, to distinguish clearly between these mutually exclusive scenarios and reformulate the ageless inquiry using the rigorous definition of static. Is there any movement whatsoever in the universe? Does the moon move at all? In light of the clarification, the reply is now academic. In order to thaw a frozen universe, it suffices that a single object move. The remaining ones automatically adjust their distance to it. And since it is a matter of fact that at least your hand moves, we can proceed to synthesize this undeniably rally into a law. I like the way he describes it. He's a pretty good wordsmith. It's just this rope theory is just so. I don't know. I don't want to try to. I got to try to use it. I'm trying to find a non-negative adjective. Anyway, the first law of physics, or the dynamic universe. An object moves with respect to at least one other object in the universe. However, before we certify our conclusion, it would seem elementary to begin defining what we mean by move. Newton considered motion to be so self-evident that he thought it trivial to bother with a definition, casually remarking, "I do not define time, space, place, and motion as being well known to all. His definitions of absolute and relative motion leave us in even greater doubt as to his understanding. Absolute motion is the translation of a body from one absolute place to another, and relative motion, the translation from one relative place to another. Translation and motion are synonyms. And we end up learning nothing from Newton's circular attempt. This is actually quite stunning, considering Newton is credited with having discovered the three laws of motion. Can theorists assert that a particle collided in an accelerator or that light travels at 300,000 kilometers per second if they haven't formally defined the word motion? Can quantum mechanics regard indeterminacy to be a principle if advocates haven't first distinguished between position and momentum? Can we take for granted that our universe is dynamic if we have but vague notions of the terms location and translate? It is inconceivable to answer such questions unless we firmly anchor certain foundations. Distance, linear space, gap, separation between surfaces of two objects. Position, an imaginary volume of space occupied by an object, the object itself. Location, the set of distances of an object from remaining matter in the universe. In a universe consisting of a single shape, the object merely has position, the object itself. For location to acquire meaning, two or more objects must inhabit the frame or field of view. Motion requires more than one location and time that we compare two locations or motions. Whereas distance, position, and location are attributes of a static universe, motion and time conceptually belong to a dynamic world, and whereas time necessarily involves observers, motion is contextual. Motion, two or more locations of an object. Time, a quantitative relationship between two locations of an object or between the motion of objects. Before and after, a second. In contrast, is a specific quantitative relation between the movement of one object and a reference. The orbit of the Earth versus the trajectory of a cesium wave. For example, energy is not an object but a concept. Energy lacks the one attribute that would allow this term to be classified as physical, that is, shape. Likewise, boundaries are implicit requisites for distance and location, a fact that, by extension, denies concepts such as love or energy the ability to move. In physics, motion is a property circumscribed to objects. For instance, the moon is an object. A photograph, a single frame of the film. The orbit of a satellite is a video, the set of locations that comprises one revolution. However, the moon can either be here or there. Like any object, it enjoys the static attribute of being at a single location. The moon does not stretch out across an infinitesimal interval of time between two marks on the line axis. The moon exists in a cross-section of time, conceptually a single cut through the time axis, that is t equals 0. The reason conscious observers perceive motion is that they remember the moon's previous location, the next to the last frame on the film. In the absence of this now vanished reference, the moon and every atom comprising the moon only have location. Each and every atom exists at the cutting edge of the universal events, at the limit of motion. In a cross-section of time, the atom itself, without memory, the moon does not move. It merely has location. These definitions now give justification to amend our first law. First law of physics, or the static universe. An object has location. It is important to note that mathematics plays no role in a static universe. There is not a single variable function or equation that can depict a physical object. Without prior experience, we cannot derive the shape of a sphere from the expression x. Or, let me see if that's x squared, or not that it really matters. Oh, x cubed, yeah, okay, x cubed, that may or from an equation such as v equals 4 pi cubed over 3. Mathematical symbols represent relations inferred after an object is observed. Hence, mathematics has no authority to tell us what things look like. It is a language restricted solely to characterizing the dynamic universe, that is, relations. Variables, functions, and equations depict motion and are limited to communicating how objects or behaviors compare with standards and references. Therefore, if mathematics understands general and special relativity and classical quantum mechanics, these theories are wholly unsuited for the task of illustrating our static universe. What does light look like when it is standing still? What would the photograph reveal if Atom Man took a snapshot of hydrogen? What is the nature of the universe before we introduce an observer? We cannot hope to answer these questions with statistics, functions, or motion embodying concepts such as energy, force, or field. What we can do is make an assumption, propose an object, and logically and empirically check whether the model successfully simulates what we observe. White light is not a particle. I could read this whole thing. It's really interesting. White light is not a package. The shape of light. Let's read that one. Okay. If all experiment results can be expressed in terms of frequency and wavelength, light is obviously some sort of wave, but what kind of wave is it? The first clue arises from a basic observation. If your hand intercepts light, this wave is not longitudinal or transverse, but three-dimensional. If, in addition, common sense leads us to suspect that there is a grand unified theory that marries light and outward force with gravity and inward force, we must simply brainstorm all the rational mechanisms that can simultaneously generate push and pull. One candidate that incorporates these features is a rope. Okay, I don't think I need to read anymore. I'll read a little bit about the rope theory, but actually you can't really push a rope very well. You can pull it. A rod would be a better thing. Really, what he needs is a rod with a wheel on the end. That's really what he's looking for. He needs a rod with wheels on either end, or maybe on one end, or white electron is not a discrete bead. Thomson, Millikan, Rutherford, and Bohr pioneered the discrete planetary model of the hydrogen atom. This prototype consists of a positively charged bowling ball circled by a much later negatively charged bead. Lewis developed the shell model, and de Broglie presented an electron that extends in an integral number of waves around Rutherford's proton sphere. Schrödinger and Born gave yet another physical interpretation by conceptualizing the electron as a cloud. The question actually begs a much simpler answer. The scientific method demands that proponents decide in advance whether a single x-orbital electron of hydrogen is a cloud, a shell, a ring, or a bead, and then use this hypothesis consistently throughout their dissertation. And the fact remains that the prosecutors have overwhelmingly voted for the bead. Despite wholesale denials and disclaimers, the architecture used in quantum mechanics is still Bohr's debunked planetary model. The American Heritage Dictionary defines an ion as an atom that has gained or lost or one or more discrete electron beads. Ridley defines electron current as the flow of discrete electron particles. Davies portrays scattering as the exchange of supernatural virtual photons between discrete electron marbles, and Ebbing depicts covalent bonding as interatomic sharing of discrete electron golf balls. Indeed, discrete electron underlie Lewis's shell of Schrödinger's lent credibility to Broglie's Saturnian hypothesis. But the matter wave equation relies on discrete quantities for electron mass and charge, implying that a finite object underlies it nevertheless. And Bohr's electron cloud is really a cloud of probability, the region around the nucleus where a discrete electron bead is likely to be found. Therefore, the hydrogen atom in use today continues to be Ptolemaic anachronism conjectured by fathers of quantum, the integral wave, the shell, the cloud, the integral was integer, shell, the cloud, and not the architectural models of a physical electron, but regions occupied by electron beads. However, the discrete bead model of the electron runs into insurmountable obstacles and must be discarded once and for all by serious scientists for the host of reasons. Among them, quantum has yet to offer physical interpretation of positive and negative. Next, Newton's first and third laws requires contact between two surfaces for one of them to change course. The quantum mechanical hydrogen atom tacitly has two interfaces, proton field and field electron. The electron bead is physically bound to and orbits the nucleus thanks to the intermediary known as field. However, field is not a physical object, but a concept. Hence, QM explicitly has a concept binding the physical bead. QM electric beads occupying energy levels. Feynman candidly confessed that physicists have no idea what energy is. The scientific method requires Feynman to tell the jury what X is, or else the jury cannot understand what he's talking about. If Feynman doesn't know what X is, then he should not be allowed to use X in his dissertation. Valence bond, molecular orbital theory hold not that the beads themselves, but rather their trajectories interact. Okay. Until these objections are addressed, scientific method requires us to reject the electron can possibly be a discrete bead, shape of a hydrogen atom. If quantum mechanics' cartoonesque atom is not viable, is there a rational model we can replace it with? Let's invoke electromagnetic threads again. Suppose that the verb of MO theory is really a noun. MO, what is MO? Oh, molecular orbital. Okay. Thus, the quantum orbital becomes what molecular orbital theory has assumed it to be for decades, a balloon. Electric and magnetic threads converge on the hydrogen atom from remaining atoms in the universe. So he's got like threads and ropes connecting everything. And eventually what's going to happen, you're going to come up with a question for him, and it goes something like this: what prevents the ropes from getting all entangled? And he admits towards the end that that's a problem. Let me see where somewhere in here he's going to admit that that's a problem. Let me see if I have it written down in my notes. Probably not. I don't really have the good notes, they're just page numbers. But at any rate, yeah, he's eventually going to come. So he's got it. Basically, he's got everything connected by threads and ropes. Okay, here we go. Here it is. Okay. The purpose of this article is to underscore known weaknesses in the quantum classical wave-particle model, to introduce thread theory. The hypotheses just formulated are pillars of quite complex theory of light and gravity. It arises as an alternative to purely mathematical endeavors. Thread theory seeks to demystify long-standing physical paradoxes, among which we include the most notorious. Okay. How do intersecting beams manage to elude interaction? The question becomes, how do threads avoid tangling? See, he knew that was a problem. This is the only question theoretical physicists need to understand today. EPR is Einstein. I forget who the other people are. Rosen and I forget the. Anyways, tunneling. Okay, it's quantum tunneling basically. Quantum tunneling, reversibility, Mossbauer effect, polarization, etc. How does a single entity generate both fringes in the double slit experiment, instantaneous electric current during the photoelectric effects? What physical mechanism embodies the two forces of the universe, gravity and electromagnetism, respectively push and pull? The other guys that we read already, have just done a better job of you got to, if you ascribe everything to energy densities and space shape, if you want to call it that. I mean, you get everything done without all the. You don't have to worry about entangled threads and ropes. Okay, this is another one of these philosopher kind of guys. Francois Tribeca Affelbaum. A Matter of Life, or Hypothesis on the Role of Electron Waves in Creating Order Out of Chaos. Hebrew University, Jerusalem. The intention of the present paper is to underline the continuity between matter and life and to advance our investigation of matter. Early in the 1st century, Oparian, a pioneer in the studies of the origin of life, reached the following conclusion. The simplest living organisms originated gradually by long evolutionary process from organic substances, and numerous attempts to discover some specific vital energies resident only in organisms invariably ended in total failure. Today, this approach is central to most theories of the origin of life. However, given the very nature of life, Oparian's statement contained a major difficulty. Life was characterized primarily by its irreversibility, while matter was then considered essentially reversible. Why is that a problem? Okay, let's see here. It'll tell us. Indeed, the irreversible matter, as expressed by the second laws of thermodynamics, according to which the disorder of the world increases constantly, was thought and taught to be a consequence of our human limitations rather than an intrinsic property of matter. The limitation is that we do not live long enough to observe all the possible states a system can adopt. Our short stay on Earth allows us to witness only those states with a high probability. Oh, jeez. I don't like where this is going. From this perspective, matter could not give birth to life since both realms were totally alien to each other, each living a different time. It would have been like watching a video film of a pregnant woman give birth and then suddenly finding the live baby in our living room. The question that seemed unavoidable in Oparian's time was, how in the long evolutionary process mentioned above did we pass from a reversible world into an irreversible one? Strangely enough, in spite of the importance of the question, the answer was found much later in Pragoni's work. Indeed, in his study on non-equilibrium thermodynamics, for which he won the Nobel Prize in Chemistry 1977, Pragogin showed that matter irreversibly is part of the very nature of matter. It is not an illusion, but the ineluctable result of the dynamics of large populations of particles constantly colliding. He showed that these collisions lead to resonances between the degree of freedom of the particle and in these resonances which are responsible for time symmetry breaking. In other words, it is not because we are not able to live billions of years that we will never see a gas mixture spontaneously separating, but because irreversibility is an inherent quality of matter, as it is for life. Matter is irreversible because it is made of a multitude of particles. Thus, this may be why, this may, by the way, lead to a satisfying answer to Schrodinger's queries: why the atoms are so small compared to our own dimensions? Why is the number of atoms so large? Thanks to Pragogin, in the passage of matter to life, there was no question of jumping from one reality to another. Continuity between inert matter and and the living realm was established. Darwin's evolution theory could be stretched to Mendeleev's table, and Oparin's statement returned to its proper place. Well, there's no Darwin's evolution doesn't exist. You don't, it's not. It doesn't work that way. Nobody's ever. This has never been demonstrated. It's never been demonstrated. It really, you just can't say, well, it happens because it happens, but you didn't see it happen. There's got to be some better explanations. All right, Pragogin studied systems far from equilibrium. This domain of thermodynamics is the domain of the living. We constantly consume energy to keep us away from equilibrium. Indeed, running away from equilibrium is at the basis of our life. It corresponds to our instinct of life. It is at the root of the teleonomic character defined by monad. In this context, metabolism and replication are seen as sophisticated strategies used by an organism to resist equilibrium. For all of us, equilibrium is synonymous with death. It is when it loses its ability to resist equilibrium that an organism disintegrates and dies. On the other hand, in the world of matter, the instinct of classical systems is to rush to equilibrium spontaneously at first opportunity as iron attracted the magnetic field. Okay, so where does that come from? Why? That. Okay, so as a conscious living being, you're going to try to avoid, say, getting hit by a car. But why? Why would a big bunch of, hydrogen and oxygen and carbon decide that it wants to not get hit by a car? You know what I mean? See, it is known that a spaceship can be projected out of the field of the Earth's gravitational attraction. Similarly, one might ask, is it possible to remove a chemical system from the field of equilibrium attraction? As long as energy is provided, a chemical system can be kept far from equilibrium. The shock was to see that under specific conditions, far from equilibrium, certain chemical systems, the oscillating reactions, spontaneously generate organized structures. These spectacular and unexpected structures are known today as dissipative structures. The phenomenon was observed as early as 1921, but for decades it was rejected as an artifact by most chemists because it seemed to violate the second principle of thermodynamics. Tremendous effort was made to fight this rejection and convince a reluctant community to open their eyes and minds to unexpected and real facts. Nearly half a century later, 1968, Pragogin and his co-workers presented a mathematical model for those reactions showing full compliance with the second principle of thermodynamics. Yet as late as 1972, some skepticism remained. What mathematical model is not reality. I would love to make this. Here's a YouTube video. Primordial soup experiment. And the human body consists of about like $18 worth of elements. So much water and so forth, and carbon and nitrogen, and you put it in a bathtub and stir it up, and wait 45 minutes. You come back, you should have a living being. I don't see what the problem is. What we want to remember about these systems is this sentence from Pragogin, in which he refers to their spontaneous auto-organization, or to what he later called order out of chaos. This is what we're not seeing, though. This is something that you need to happen, but there's no mechanism. This is actually not a mechanism because you can't see it. You wouldn't, you wouldn't do that experiment. I mean, you could try that experiment. Maybe the only reason we don't, maybe the only reason I don't think it could happen because nobody tried it yet. Go and try it. Such a order stemming from activity of billions of molecules seems incredible. To change the order all at once, molecules must have a way to communicate. The system too has to act as a whole. Though this conclusion leaves us quite perplexed, coming from Prigogine, it is worthy of consideration. In 1924, Louis de Broglie, considering the dual nature of light as suggested by Einstein, thought of the possible new nature of matter, corpuscular and wavelength. De Broglie suggested the following mathematical relation which assigns a specific wavelength gamma to any particle of momentum rho. Gamma equals h over rho, h equals Planck's constant. Since then, this relation has been confirmed with great success throughout experiments on elementary particles, not only electrons, but also atoms, neutrons. The correspondence between experiment and theory is impressive. 2 years later, in 1926, Schrödinger found for bound particles such as electrons the function that describes this wave, the wave function that revolutionized physics. Consequently, the building blocks of our universe became hybrids of two components, one exhibiting properties taken from the physics of waves and the other exhibiting properties taken from the physics of rigid bodies. However, even today we have no precise idea what this hybrid really is. This is what Heisenberg's uncertainty principle stipulates. If one focuses on one part of the hybrid, the other becomes hazy. Moreover, when scaling up the phenomena and dealing with large populations of atoms, the electrons, the wave component of this hybrid seems to be lost, and one is left with a rigid body. Indeed, the wavelength associated with any macroscopic object is smaller than the dimensions of any physical object, and no wave phenomena such as interference can be observed, not even for dust particles. This make me think of something about this here. Okay, so yeah, I like to keep in mind that reality as we experience is a combination of certainty and uncertainty, determination and undetermination. You know, like determination and chance, certainty and uncertainty. There's both things in the mix. It's very, I don't know what you call it. It's very weird, and I think that's what he's kind of referring to that here, and only instead of certainty and uncertainty, you know, it's wave and particle. But similar reservations were expressed. Okay, well, de Broglie. Okay, hold on. Let me see. Where did I leave off here? I want to read more of this. Wait a minute. I switched pages to. Use the wave function with hybrid. Moreover, there. However, we should not forget that at the atomic scale there is no such thing as a rigid body, and that what we call matter is an aggregate of these strange hybrids, an intensive state, by analogy to intensive properties of something we still cannot grasp. De Broglie died in 1987, witnessed the tremendous success of quantum theory, but did not agree with the abstract interpretation given to his wave, he wrote. By which strange coincidence could a representation of probabilities propagate in space through time like a physical wave able to be reflected, refracted, and diffracted? And you know, that's the same thing I always said. I didn't know he agreed with me. Similar reservations were expressed by Schrödinger. The mathematical representation used by theoreticians must be only a manner of describing with precision the nature of the considered phenomena and must not be reduced to a simple intellectual gymnastics. You know, this is interesting. See, when you are presented probability waves in school, you're not taught that, you know, de Broglie, the founder, didn't agree with it. You know, it was just a mechanism that coincidentally was working in a way to mathematically describe, but you're not taught that. You're taught it as sort of like it's a dogmatic, it's a dogmatic fact or something. As well, Einstein and Planck, Einstein refused to accept that all we could observe was a probability. He wrote to his friend Born, "I'm not satisfied with the idea that we possess a machinery that enables us to prophesize, but to which we are not able to give a clear sense." For Einstein, quantum mechanics was not wrong, but incomplete, unfinished. Since the interpretation given to the equation of quantum mechanics has led to exact predictions and as such forms a cornerstone of the highly successful quantum theory, attempts to give a tangible description of the wave function of the electron have declined. Indeed, it is so hard to envisage what this wave function is that we cannot but wonder if solving the wave-particle duality enigma might not be like transcending body-mind duality. However, after this digression, we return to the dissipative structures and the communication between molecules mentioned by Prigogine. During an oscillating reaction, there is a reversal of the spontaneous motion of electrons from maximum disorder. The most probable electron arrangements to organize structures. Prigogine said that this organization is the result of communication between molecules. Our hypothesis is that if communication between molecules indeed exists, it is accomplished through the wave associated with their electrons. Even though these waves are not directly observable, they may induce observable effects. It seems plausible that information about these structures may be transmitted through coherence between these electron waves. So you do the experiment, you put the $18 of elements into the bathtub and come out with a human being. Okay, so that's that one. The electron is an extended structure in cosmonic gas. Adolphe Martin, Montreal, Canada. The ether, vacuum, zero-point energy, or space-time, etc., is modeled as a gas composed of elementary particles called cosmons. Physical fields are defined by mechanical properties of a cosmonic gas. These gas properties are necessary and sufficient to derive the structure of the electron as an extended fundamental particle based on known measured properties such as mass, isospin, hypercharge, and two concentric charges of opposite sign equivalent to the single electron charge. Introduction. Previous studies of relativity showed that Einstein-Minkowski space-time is an isomorphism of Galilean space and time, thereby unifying electromagnetism with classical mechanics and making it possible to use classical mechanics to describe the nature of physical phenomena. A new model is proposed to explain known physical phenomena. The material substratum is modeled as a gas composed of elementary particles called cosmons, which are agitated in all directions. This cosmonic gas is assumed to pervade the universe even the space between and within fundamental particles. It will be shown that the well-known mechanical gas properties are sufficient to account for electrical, magnetic, and gravitational fields and other physical phenomena. Arguments will then be presented to show that fundamental particles are spatially extended configurations of cosmonic gas. Lastly, the results of calculations to demonstrate electron structure will be presented. Cosmons, and a lot of these theories have similar themes. They rely very heavily on the structure of space or ether and that kind of thing. Cosmons have no moving parts and hence no internal energy, and according to Einstein, no rest inertial or gravitational mass. The space between cosmons is absolute void. Cosmons are thus alone in the universe, and there are no fields or forces at this level. The sole property of a cosmon is diameter, determines a certain volume of space that is forbidden to other cosmons. The cosmonic gas is the substance of which the universe is made. Interaction with other cosmons occurs only during encounters where there is an exchange of velocity components along the line of centers with a quantum space jump of 1 cosmon diameter. The velocity components normal to the line of centers remain with each cosmon. Between encounters, cosmons move at constant velocity, speed, and direction. Laws of physics and cosmonic gas equations. In accordance to kinetic gas theory, cosmon velocity varies from 0 to indefinitely large values. And in Maxwell distribution, the mean speed of agitation, c, is 5c squared equals 2c squared. I'm not sure how that works. Oh, there's a capital C and a small c. The small c is small. The capital C, I guess, is cosmon. And the small c is the speed of light because they have 0 spin. Cosmons are bosons. And energy varies according to Planck's distribution law. Classical concepts such as mass, charge, magnetism are properties of the gas at this level. Wow. Oh boy. Gas vortex. Fundamental particles are thus seen as spinning concentrations of gas vortices exhibiting gradients of pressure, density, and temperature. As a result, a moving fundamental particle will automatically possess wave properties. The wave-particle duality is thereby explained. According to Maxwell, wherever the electric field has a divergence, sum of partial differentials, there is an electric charge density. Consequently, fields, both electromagnetic and gravitational, which extend indefinitely far in space, as do their charge, mass, and energy, are part of the fundamental particles, which in turn must also extend indefinitely far in space. The general applicability of wave mechanics, the apparent non-locality of fundamental particles, the diffraction phenomena are thus explained. When Coulomb law is modified by replacing the invariant E with a charge E, which varies from 0 at the center to a radius, the problem of infinities is removed, and with it the need for renormalization. In gas dynamics, there are 2 very stable velocity configurations in 3 dimensions. Both have a toroidal geometry. Circular vortex. The circular vortex is analogous to a circular smoke ring. A series of tori are centered on a cosmon axis. Their meridians defined by planes passing through the axis being circulars whose centers are described a circle in the equatorial plane normal to the axis. These torus meridians are streamlines of the gas. This pattern is rotated about the axis, making it spherical. Okay, so here's a little illustration. Okay, this is one of these toroidal things here. Spin vortex. Planes normals of the axis cut the toroid structure, circular lines. Spin vortex geometrical arrangements of the spin vortex, also called spherical, is the same as the circular vortex. However, the flow of the vortex lines are interchanged. Streamlines are circles concentric with the axis, while the vortex lines are the tori meridians. This pattern exists in every spinning concentration. Thus, the closer the meridian circles of the tori, the higher the rotational velocity. In purely mechanical configurations, irrotational flow, the rotational velocity becomes mechanical spin, and neutral currents follow the streamlines. In electrical concentrations, rotational flow, the pattern is equivalent to isospin, while electrical currents follow the streamlines, and the vortex lines are the magnetic lines of force of the magnetic field. I mean, that's kind of interesting, but how do you get them all lined up? I'm not sure how that happens. He's got this, so he's actually got it lined up, to try to describe all the fundamental particles. The circular vortex pattern combined with the uniform flow pattern produces the flow around a sphere. There is no flow across the sphere, so the gas inside the sphere moves with it. The gas outside the sphere, however, does flow past the sphere. This combined velocity pattern accompanies every concentration moving in the gas, including the photon. The Compton effect is a vectorial exchange of energy and momentum components of the circular vortices. The higher the velocity of the concentration, the higher the velocity along the streamlines, the greater the vorticity on the vortex lines. At the two intersections of the axis of the motion with the sphere, the velocity falls to zero relative to the concentration, and the pressure goes to a maximum. The distance between these 2 points is the de Broglie wavelength. The sphere is infinitely large at zero velocity of the concentration and decreases in size as velocity increases. It shrinks to zero at infinite Galilean velocity, or when Einstein velocity is c. The relation between these two velocities, v over c, tangent h v over c. Similar purely mechanical patterns at constant total pressure account for the kinetic energy of neutral concentrations. The flow pattern circular vortex due to the concentration's velocity combined with the isospin pattern spherical vortex, when viewed in the direction of motion, produces a precession of spin axis to the left normal to the velocity of all 1/2 spin matter particles, antiparticles precess to the right. For integral isospin, -1, 0, +1, the particle spin is to the right or left because the spin axis is parallel to the velocity in the particles. The streamlines of the spin vortex are parallel to the vortex lines of the circular vortex, and similarly the vortex lines of the spin vortex are parallel to the streamlines of the circular vortex. There is no induction and no precession of the spin axis. So basically it just, depends on the orientation. Kind of like, are you like just as a rough example, is the way the moon rotates at exactly the same rate that it orbits, so that it's always facing the Earth. That's those kinds of things. There's other dynamics to it, depending on if you got it, if it's moving in the same direction as spinning, or it's moving in the opposite direction as spinning, that kind of thing. But I'm not sure. I guess he's just saying that, okay, if you got all these vortice dynamics, it gives birth to the characteristics of the fundamental particles. And that's the end of the book. That's the end of the book. Wow, that was exciting. That was a fun That's actually, I like to think about that kind of stuff. You know, So here's the thing now. I am putting up videos on LBRY if they're controversial. So I'm not putting up my regular videos on YouTube anymore. I will advertise on YouTube that I put a video up on the other channel, the other platform, and so I'll do that next. I'm going to make a little video because I've made a couple controversial videos about current events that I will, I have up on library. So anyways, I hope that you find that something interesting to think about. It would be kind of nice if they had the electric universes model in there with the infinite regress of electrons and protons. I think that's how they're doing it. I mean, that's, yeah, you got it. Well, electrons. Here's okay. So you got an electron. Inside the electron, you have to have a positive charge, and then inside that positive charge, you have a negative charge. That's the infinite regress. I don't know if they actually give them particle names. I forget exactly how they did that. He kind of, I think he describes it as having a proton inside, but the thing is, what happens is all the mass and that kind of stuff. I'm not sure how he puts it all together. But at any rate, thanks for watching. If you did, this is the kind of video, it's like 3 hours, 20 minutes. You put this on if you have to go to sleep. I'm sure it'll get the job done. So, all right, take care.